Welcome everybody, August 16, 2023, Propeller Live Forum. People are still rolling in and we'll let them come in and take their seats. A lot of people here today. Today we're talking generally about two things. The latest release for the brushless DC motor control system that Stephen has worked so hard on. And we have some hardware that goes with that for sale. And then the second big topic is Chip will share the file system today. And we'll take comments on that. And John has already worked with it quite a bit. So a lot is already happening. And I think for the brushless DC motor, Kevin might show just where he's going with his Kevin bot. And Shannon has something to contribute there too. So I'll move through that kind of fast. If you didn't see, Kevin had a story published in the McKinney paper where he lives, and I'm just going to plop that into the chat so you can see it. And although he prominently mentioned parallax, the reporter didn't include us, but you could see the hardware all over his desk. So he's working on Kevin Bot 3. And he'll tell us about that too. Our next 4 Propeller Live forums are enabled for your registration when you want. We don't have topics yet, but as the time gets closer, we'll probably replace these images with pictures that relate to our topic. So September 13, October 18, November 15, and December 13th. And they're all right here on the events page on our website. And I want to point this out again because there was a time when I maintained a forum thread with all of these when we started this during the very beginning of the pandemic, but don't have time to do that anymore. And really should put a note there. Someone should that just to go to the events page. I thought I did, but maybe I haven't. So I'll ask Ari to help me out with that if he's around here. So they're on the events page and you can go there and sign up for them anytime you want, or else you'll get my email. Okay, so first topic. Was there anything else, by the way, like support questions or other big things before we get into this stuff? Anybody? Okay, we'll have intermission.
Ken, I could probably do 2 or 3 minutes on the latest visual effects on Visual Studio Code.
Okay.
Latest appearance.
Cool. Got it.
Did I show that last time? I don't think I did.
No, I think maybe it was work in progress. I don't know, I saw it somewhere, maybe with you. It had just slightly lighter hues of what we've been using.
That was me. That was when you and I were talking.
Yeah, let's look at that today.
Okay.
So for quite some time, I've wanted to get my hands into this brushless DC motor controller because I like building robots and putting things together. And I'm also a pretty good test of a non-technical user. So my electronic skills are lower and my coding skills are lower, but I can put things together and make things work and modify things. So I just kind of want to see what experience our customers would have. And this picture does not show our customer experience. That's my experience when I hooked up power backwards at one stage, which is just a reminder when working with these bigger robots and lithium polymer batteries, you got to be really careful. And this was on Saturday afternoon, and that sent the Sonatrol service to make a bunch of phone calls and a bunch of hoopla. And even though the smoke was cleared out of the building, our sensors went off. And I was trying.
Ken, can you show the video of that thing burning?
Yeah, I'll find it.
There's a picture. So that was, anyone want to guess what actually burned up?
I'm surprised by that location.
Board trace?
That's the 5 milliohm shunt resistor to ground.
Jeez.
So there's a lot of juice flowing through that. I don't know how that happened, but
That's stunning.
yeah, usually it was the chips that would blow up or the FETs, but
Did you say 5 milliohms?
yes.
How do you get milliohms?
Well, we would measure millivolts to determine the current through that leg, but I don't know, you know, oh, wait a minute. Gosh.
Yep.
I don't
I
know
do-
what would cause that kind of failure. I suppose if you hooked the LiPo battery right across somehow, that resistor, maybe you could burn it up there, but I don't know if that much juice was going through the FETs to cause that thing to burn, because think how much current you have to put through a 5 milliohm resistor to get enough power to burn it up.
Well, anyway, through all the excitement, I did get a picture, and I really don't know what I did, but when you're at the factory, you can go grab more hardware.
We don't know what he did.
Right. So we won't worry about that for now. It's just to use caution and be careful when doing this. Okay. All right. So moving on. Here's
Good
the
question. Does anyone hear me?
Yeah.
I'll show
Okay,
you. I'll
it's
show
just
you
not showing the
video.
green.
We'll talk about some of the goals, the features of this whole effort, and then what I think the minimal hardware is to use this stuff. Minimal is also unsafe, but that's kind of what I wanted to show. No fuses, no switches, just things that are properly wired together and are generally safe when they're wired together. So I'll show you that today. Then what optional parts you might need to make a more complete system. And then we're having a massive sale right now. So get your credit cards ready, and we'll accept them momentarily. And I don't know how long we'll keep that rolling, but we'll have that sale going just for a little while. We just want to get more users on this now. So, okay. First off, just a short video. You guys can watch it with me. And I just have to make sure that the audio carries through to you so you could hear it. I forget where that setting is in Zoom so that when I play a video, you could hear it. Okay, well, I'll talk you through the video if you don't have audio. Do you have audio? All right, so basically, this is just bare bones. This piece of wood is a drawing on Stephen Rocco's GitHub. And you can order this file, send it to send cut send in Reno, and they'll send you back this wooden platform for $30. And then you could just put our wheels on it and put a couple casters on it. And it's a quick process, takes like an hour, or if you want to see it, here it is in 30 seconds. Okay, and then here's the absolute bare bones hardware on top of it. It's a quiet system. It's very smooth. It's really fast. It's about half speed. Yeah. Really fun to work with. You got to protect your baseboards in your house. Okay.
And your ankles.
Yep, and your ankles. So just give you a better visual of it here in front right now. You can see just how I set it up. Okay, there's your hardware. And then on the bottom, I just put a LiPo battery. There's really not much to this. So it's a basic system. As far as robot platforms go, it's just a place to build your project. It's not like the award-winning multi-purpose, super useful robot platform. It's a piece of wood and you can drill into it. You can tape stuff to it. You can paint it and you can build all over it. All right. So that's the purpose of that. And
Ken, if you want to be a
yes.
little bit more flashy, Send Cut Send usually even sends you stickers.
Oh, okay. So the build was a success aside from a small fire. And moving on. Okay, so some of the goals, going way back to this project, we started this about 2 years ago. And the idea was that the motor control, brushless motor control of these hoverboard motors in particular would be really good for our mid-size and our large robots. And two goals really. One is to have a reference design for the Propeller 2. because this is a good application of it. All of our chips have always done very well in robotic applications. So the whole thing is open sourced, and it's the hardware's developed by Chip, by Doug, by Steven, our manufacturing staff, and then the software and all the resources and the documentation is hosted here on Steven's GitHub, which is really super, very complete. And I cannot do this justice in a slide or two because everything is there. And it's many, many hours of work, and I've tried to boil it down just to a single slide. Not possible. So go there to get everything. So in addition to having a good reference design, we have a robot platform that you can build yourself if you want to build a robot. And if you're interested more in the reference design, everything here is open source. And I'm also posting the files for the motor driver in case you want to build that onto your own board. So all free, okay? And generally, just head into the mute button just for a minute. You can unmute yourself if you want to say anything, it's no problem. There are 3 ways to control this, 3 kinds of examples. One is from the Propeller 2, that's what I was showing. And then there's the Fly Sky using some of Johnny Mac's code. And then there's the serial interface, which is what I hope to show off next time. There's a really nice user interface that has all kinds of type of control, power, direction, distance, various forms of motor stopping, acceleration control, and then you can get all these values back from the system too.
So you're using the Fly Sky S-Bus with that?
I was using just the P2 to control it.
Uh-huh.
Yeah, Steven's setup is with the Fly Sky at the moment.
Nice.
I was using Fly Sky, but I had other kind of lower level problems on to back up and go backwards way down the system to make things smaller levels of things work and do some troubleshooting. And during that, my Fly Sky became unbound and I was never able to get it bound again to the receiver transmitter.
Ah, okay.
Yeah, so I gave up on that. I really don't know what happened, but $60. And after giving them $460 of my time, I decided to bag that. And I'll order a new Fly Sky. Someone out there knows why it won't bind, but yep. So there are 3 ways. And Steven, is there anything you want to say so far? I didn't want to have to make you prepare anything, but.
No, it's first of all, fun to see you working on this. And secondly, the exciting part about adding the 2nd, 3rd, and 4th people using the project, I think Michael got there first and Ken got there second, and soon we'll have Kevin playing with it, is y'all keep me honest. Apparently in the latest 4.0 release, I introduced a regression in 6.5-inch motors. Didn't work very well. And we found and fixed a couple of problems as Ken was working, and thank goodness it's lively again. Secondly, if you're testing in your garage with one of these platforms, and I test with the Fly Sky enabled, so I'm running hand controlled, and I may not be the best in responsive controlling and understanding what I'm creating. And so move the expensive things out of the garage first, please. I have plastic trash cans in there, and this thing will vault itself so fast across the room that you can easily dent plastic trash cans and small metal objects. So it's just be careful. There's a lot of power here. We both ran with 5S batteries, the 18.5 volt guys. You can run anywhere from, I think, 7 to 12 volts all the way up to 24 volts with this thing. I have the power. While you're there, I have the power constants in the file. And so as you describe your setup in the configuration files, describe what power you're using, and the system will adjust automatically. Ken, if you would scroll down to the system diagram on that page. I think there's a system. Yeah, there you go. I would talk to this because it's kind of fun to look at. We have the, hello?
Yep. Zooming in a little bit.
Okay. You see the little gear icons, that's meant to represent that we have these different cogs allocated. The bottom right-hand corner is your main cog. And when you're running 2 motors, we have a cog allocated to each motor driver. And it's running 2 loops in PASM code in that driver. There's the inner faster loop, which is controlling motor position, just controlling the current state of the motor and making sure it gets the next commands in time. The outer loop then, wow.
Sorry about that. I was trying to
No
give you a better
worries.
picture.
The outer loop in the green is actually the steering, the ramping up, ramping down, changing directions. That's all done by the outer loop. The position tracking is then maintained by a separate cog watching status outputs from the drivers. And so you see the white one with the gear icon. That's the position tracker. When you're running single motor, there's a replacement position tracker inside of the ISP BLDC motor next to the green. There's a white one in there. When we're running 2 motors, we don't use the 2 independent white ones. We use a shared white one in the steering file. And now it's doing position tracking. So when you tell this thing, when you command it, you're going to give it a direction and speed in some of the commanding forms. You can give it a direction speed, and then you can say, okay, but do that for 15 seconds. And so when you're giving it direction and speed, you're actually talking to the green motor drivers. When you're giving it stop after, you're actually talking to the position tracking object. And then when you say wait for the motors to stop, you're actually talking to the top level cog. So the interface then interacts with the different pieces, so they all run autonomously and make it real easy to use. And Ken can show his main code there, and that would probably reinforce what I've just been saying here. When you are working, yeah, let's look at the main code. And now you can see the calls. And so we see drive with direction, 50% power straight ahead, stop after time 2 in units seconds, and then wait until motor done. Those are talking to the 3 different pieces that we just talked about. The first one's the green piece, the second one's the white piece, and the third one is your top level. Just waiting for things to complete before you start commanding more. So really simple interface to use. Examples for all these code. There are demos with FlySky, demos single motor, and demos dual motor. The last thing I'd say is there's also a demos where the P2 is listening over serial and responding to whatever comes over serial. You can put an Arduino out there or a Raspberry Pi out there and drive this thing over serial. It's a real simple interface. And I provide Python examples for speaking over the serial port to the P2, and you'll see the interface looks very similar to these calls from the Python API. So there's also a system diagram in this serial MD. I don't recall which MD file it is. But Ken, if you'll stop share, I can share it.
Yeah. Okay.
And so that would be this screen here. Okay. And so you can see here's the single, the dual motor example. And if I flip this over, here's what it looks like with serial. Can everybody see that?
Mm-hmm.
Does it need to be larger or anything? And so with serial, what you've got is another cog listening on the serial port. And it has a queue object wrapped around it. So the serial port's constantly receiving stuffing into the queue, and then the host serial is receiving from the port, handing it to the queue. And then what happens is the steering object then services from that queue and just does whatever shows up in the queue. So now you've got the 1, 2, 3, 4, 5 cogs running in the P2. And then I have an example, a serial, a Raspberry Pi talking serial to the P2. On all of these, you'll see, I'll go back to the top level README. On all of these, you'll see the demos are here down the bottom. And I recommend which boards to use with these. When you're starting to do the FlySky and the serial and 2 motors will all work off the smallest edge, the mini edge. But if you're going to add any more sensors and things, and for instance, you need underglow on your robot carriage or stuff like this, you'll want more pins. And if you're putting cameras on it, things like this, you want more pins. And then you go to the larger boards. At the top of the file, I just remind you what the boards are that we support. All 4 of our P2 boards are supported, and the 2 edge breakout boards, the larger with all 4 12-pin header pairs, and the smaller with 2 12-pin header pairs and extra 12-pin header. Both of those are the 2 we recommend for mobile platforms. The Johnny Mac also works, it just takes up a little bit more space. So feel free to use whichever ones you like. It's just fun. This picture shows we also support the smaller motor without the wheel, the Doco 4,000 RPM thing. 40,000, 4,000, I don't remember. Okay, I think that's all I had for that, kid.
It's super.
How can I stop my share? Where are my controls? They moved.
I
off.
took it from you.
Thank
I have
you.
a question.
Please.
What is the function of the Raspberry Pi in this instance?
It can be, you can do a number of things with it. The point was to show you that you can drive the robot with an Arduino or a Raspberry Pi. It is sending the controls for steering. It's an easy way to attach camera and use image recognition in your cameras. It's also an easy way to put a web back end, so you can literally connect your browser to your robot, then control it from the browser on your mobile phone. So you can do all sorts of things like this with Raspberry Pi. You could also put an HDMI display and, you know, have it showing you things of what it's seeing or interpretations of its images that it's seeing. Whatever you'd like to do there.
Yeah, whole computer. Briefly, Stephen, you mentioned the configuration and different
Yes.
boards, different motors and power supplies. So I just wanted to show that config file because that was really easy to use. So identify the pins and then the battery you're using and then the board type and just comment them out and then you're away we go.
Right, and I put a bunch of sample configurations in there and I have them all configured. I have them all commented out. So all you have to do is remove or add a single tick. If you add one, it uncomments a block. And if you remove one, it comments the block out again with just the top braces. And so it's really not hard to do. I have examples in here of a number of different kinds. So you can pick the one that's closest to your environment and just enable that and then set up the pins. When you're using an HDMI display from your platform, I will put in a routine in one of the next releases so you can, one of the things I do in the top level is I do pin validation to make sure that your constants are all valid constants for motor control speed, battery, and stuff like this. And it will not start anything up unless they're all valid. I will do the same if you're using HDMI. I'll put that in the demos too. It's real easy to accidentally overlap the HDMI specification with one of the motors and then life is just bad. And so I'll put a cross-check to detect that case.
Well, every trap that existed, I found, right? And I jumped right into them.
You're excellent at that, Ken. And frankly, I say that tongue in cheek because it's also really important to have people like you to make sure that we've tested this documentation and make sure that we've tested the code. It all works as advertised. So thank you so much.
Yeah, you did a great job and you dealt with me really well. I mean, I'm the kind of guy who will come to the GitHub and then go here to the code and then download the whole zip. And then I'll go to the individual source pages and maybe get something there. But really where you need to go is down here in the lower right, the releases section, the latest 4.2.0, which was yesterday. And we did find a few things with the debug and file mismatch that we got straightened out. So now it all works really nicely. Thanks, Stephen, for your patience there.
Oh, I'm always glad to help. And for any of you, if you're ever working with my repos, there are ways to contact me from the repos, and feel free to contact me directly. I always enjoy. If you need face-to-face, I'll Zoom with you. Make it really easy so we can talk about the issues you're having with the objects. I like to play with this stuff. You'll see videos up there. If you go to links about the motor control and the motor control forum, you'll see links to videos of my platform in operation with FlySky and things like this. It's fun.
Where are those located?
The links are at my YouTube site in the P2 forums.
Okay.
For the BLDC
Perfect.
motor control, you'll find links referenced in there.
Good.
I can also put them up on the.
Yeah, let's get them in the chat. So what do you need for the bare bones setup? And in the past, we may have bundled this up and stocked all the hardware, but we don't really have a lot of time to do that. And people can go to Amazon and get things on their own. So the core stuff you need from Parallax is right here, shown in the picture and then shown on this list on the left. And it consists of an edge module prop plug, a breakout board, universal motor driver, 2 of those, and then 2 of the caster wheels if you use this platform, 2 of the hub motors. And I'd like to point out that we really want to get some users here. As Stephen mentioned, I was probably the 3rd user. the first being Steven and then Michael. And then the only reason I beat Kevin R is because I hadn't sent him any hardware yet. So let's get some eyes on this and really mature this, because this is a great application of the P2 and it's fun. So with the kit that we have right now is a bundle, and we're calling it the BLDC motor control with P2 Edge Super Bundle. And we sell these parts for $700, and we put them in a bundle for $400. This is not any kind of money maker for us. This is just a user excitement, user eyeballs, and hopefully community effort to get some of this moving, and then also to reduce some of our inventory, which has been sitting because we hadn't really formalized things to this point yet. So what do you get? And you can buy these things individually too. So you get 2 hub motors, and then you get 2 of the mounting blocks, which are really nice. Those are machined by Doko, who has the CNC shop behind Chip in Red Bluff. And then we also took 2 of these chair caster wheels and made a little adapter. So you get 2 of those plus the wheels. And then here's the nice thing. You'll notice that Universal Motor Driver P2 add-on board ×3. So we put 3 of these in the box, and we've done that because there are probably other people out there like me that blow things up. And I just really hate getting stuck. Like, I started this project at home. I thought I had everything I needed. And then boom, boom, Saturday morning, I was in Rockland, 100 miles away. And people don't have a parallax laying around when things go bad. We have our junk drawers and parts and stuff, but the motor driver boards, you can blow up if you reverse power, you don't have fuses. If you're anything like me, you can wreck stuff. So we put 3 of those in. And then an edge mini breakout, an edge module, a prop plug, and then some other little bits and pieces, okay? So here's a link for that. I don't know how long I'm going to keep this up, to be honest. I'm not trying to add pressure to anybody to buy anything. But when the inventory gets down, I'll probably pause it because I don't want to reorder like these hub motors from China. They've gotten stupid expensive. They're very heavy. The boxes are breaking open when we get them in Rockland. The whole thing is just, we prepay. It's painful. So you could buy, and then we'll stop it when the inventory gets a little bit lower. And then the wooden base, as mentioned, that's on Steven's GitHub site. You can just grab the files. It really took a few minutes to get them to send cuts. Then you could pick your material. You can make a cutting board, plywood, whatever you want. So other stuff you might want, there's a whole list of these parts, which I'm going to paste into the chat right now. And I'll show you the links on the next page for people who are just watching this on YouTube. But right there into the chat coming at you, or links to various Amazon stuff, which you can see here. And then in addition to that, I think you would probably want to have, so we're using the power supply thing, 5 volts for the edge, and then your power for the battery for the motors, of course, are 2 different voltages. And so one easy way to get 5 volts is with these power banks that are everywhere. And we have a little USB to 2.1 jack, which you can draw from this. So it's an easy way of dealing with 2 power supplies, is to use that.
Yeah, and alternatively, I used a step down mechanism from which will handle any of the battery sizes and give you a good solid 3 amp 5 volts. Reason I selected 3 amp is that you can power the P2 and the RPI at the same time.
Yeah, I know when I add a pi, I'll be dealing with the better power supply. So here's a list of those parts, which I just put in the chat. And then Michael also used for his some switches that were really nice. They were like 12-volt RV switches, DC switches that were super friendly. I didn't see them on this list, but there are a whole bunch of them on Amazon.
I think also if you look at the bot that's being made, you can probably tell some of the background of where we come from. My guy uses a connector system that we use on amateur radios for power.
Mm-hmm. And I was using RC style stuff.
Right. Battery system uses RC, and then the rest of the power system uses amateur radio connectors.
Other things you might need, lots of hardware like I show here is always good to have. Screws, nuts and bolts, hex keys, solvents, yada yada. Computers, voltmeters, fire extinguishers. Okay.
Some things should be done outdoors away from anything flammable.
Yeah, I have the record of the most fires in the office. And I'm just trying to make sure Andy doesn't see this video today because he's always after me for doing things the wrong way.
Points for setting alarms off in your environment.
Yeah. So what's coming? This is something coming that will also go with the system. This is a tracked platform, and this is using an extruded aluminum track system that joins together that can also accommodate some pads on it. Some hard rubber pads, like I think out of food conveyance type systems. And this system is being prototyped and made right now in chip shop. So we'll see this pretty soon. And that's about a 2-foot long platform, I think by 18 inches wide. And it's going to be really, really capable. And notice it uses also a brushless motor. So we will be able to drive that with the same electronics. These
Can
are
I
all
make a
machine
comment
tools.
on that?
One more time, Grover.
Yeah, I read your first description of this mechanism, and it was fantastic. There was a lot of feedback from a lot of people on that. And what dawned on me was the fact that you might need to make a smaller version of that eventually for different kinds of applications, like a search and rescue robots that can crawl in under debris after a disaster. Smaller versions of that would meet those requirements, I would think. And in other words, the same thing you're doing right now in this size, this platform, but much smaller. Just wanted to make that comment, but that was what dawned on me from reading all those comments from people.
Yeah, that's good. I totally agree. Lots of ways to go. I mean, once you start running something with tracks, I think there'll be a little more learning that occurs because tracks, they have to break free for a robot to turn, and they could really tear things up if they don't. They have to be on dirt. They have to be in some surface they could unlock. So be watching for that. We're getting prototype. Maybe we'll make a smaller version someday. The cost should not be out of the world. Doug, who's making it, really wants it to be quite reasonable. And these parts that you're looking at were originally designed by a friend of Chip and I's and Doug's many years ago, and he just couldn't quite get them to market. So we're doing that now, finally. And then where to go with this?
Question about the brushless. Wondering if we'll be able to run it off this battery I have. It's a 12-volt lead acid, 18 amp hour.
Anyone know? I think you might be a little low on current, but if it's
No, that should have plenty of current. It's just 12 volts. It should be plenty, right?
I would
probably.
think so.
Yeah, I mean,
Think so. With the voltage, you're limited. Your speeds are limited based on the voltage, of course, that you can achieve, and your current that you can drive it with. So the driver is well aware. You just tell it it's 12 volts, and it should operate normally. I think you'll still be pleased with the performance.
Okay.
yeah, let us know how it goes, Kevin. So what are the next steps with this? Stephen notes on the GitHub to add in some reading and scaling of current draw, acceleration control, and that's again the built-in spin up, spin down ramps with something better. I mean, it works nicely now. There's always room for improvement, right?
Oh my
And
gosh,
then-
I'm really looking, if I may interject, I'm really looking for somebody that's a lot smarter with motors. It really looks like that we could be live adjusting based on the performance of the motor. We could be live adjusting our offsets of Hall relative to sensing to keep maximum performance. We're not doing that right now. They're constants. And we could be be a lot more sensitive to the power we're drawing at any moment and adjusting our behavior as well. So those are two opportunities in the driver where we could get a lot better and more intelligent. And likewise, the acceleration stuff. I'm just not trained in this stuff. I don't have any experience. And so somebody knows how to do this with servo motors or the DC brushless and wants to talk me through it. I'm a great learner, and I will put in code very quickly once I understand how things work.
Exactly. And that brings us.
Stephen, this is Shannon here. I'll be talking a little bit more about my experience with your code recently, but all the things you just mentioned are in fact all the places I intend to go with this.
Beautiful, Shannon. I
So
appreciate
let's do it
the help.
together.
Yeah, and I can easily open up these GitHub repos for, I think you can already do commits if you want to modify the code yourself. Or likewise, if you just want to work with me, I'll help you shape the code and give you things to play with.
At the moment, I'm happy to let you do the spin, and I use it from C.
Nice. Okay.
And that brings us to community. Yeah, we need some
I
users.
also do a lot of translation work from C and C++ into Spin. So that's easy stuff for me. So thank you. I look forward. Sorry to interrupt, Ken.
Yeah, well, we welcome Shannon. That's great to hear. More users, please. And then at Parallax, we'll just keep building the hardware, and our next steps will be to put a Pi on this to show how that could be used, maybe with some vision or some simple serial interface, just to show people because the Pi is so popular, and then to try it on other platforms like this robotic boat we have in the office. And so, Stephen, I just want to really acknowledge you for your super awesome work here and the documentation and the completeness of this and how much fun it is to use.
Oh, thank you.
Yeah, it's incredible.
I do this just so people can have fun and play with the stuff I create. So anytime anybody's happy, please let me know. It just keeps me going.
Great. And that was it for me. And I think, Shannon, you had something, maybe, I don't know if you're showing anything, or I just want to jump in and then we could get a quick look at Kevin's progress.
Sure. I've got not a big presentation. I've got a few, I'll share my screen a little bit, a couple pictures. So about a month ago, I spend a lot of time in a tech startup, a hardware startup incubator, and saw one of the new teams had on their bench actually this robot kit, effectively. The hub motors I recognize, my favorite P2 Edge, and a couple universal motor driver boards. And I thought, well, one, great. I didn't have to sell them on that. They've already bought in there, and there's 2 weeks demo day, and I know there's nobody else in the shop that's proficient with these, so I jumped in there and bullied my way into their project and helped them out, get that going. I'm going to share a few. Well, maybe I'll share the whole thing and you'll watch me flick through pages here. That one. So they were making a cart, radio control, or locally controlled anyway, that can ride over to a bed and scoop somebody off the bed like a wheelchair and drive them away. And they had already your two motors, or those two hub motors on there, stood out. Here's the implementation of it. All the guts inside that black box with the gangly wires hanging out of it. So there's two drive motors. You went with the brushless motors. And we're still a little back and forth on that. But there's brushless in there at the moment. And there are 4 linear actuators controlled by rocker switches, for both directions. And we ran it at 12 volts just to get it spun up, but expecting 24 here. I've got a new version here. I'm going at 24 volts. A little control pendant, joystick, and 4 rocker switches. There's an RP2040, the Pi Nano or Pi Pico Nano, I don't know. Anyway, it's the microcontroller. That's a nice little part too, but that collects up the data, sends it down serially. And I made just a little pretty simple protocol here. Framing byte, then sends the speed and the direction. Those are the 2 axes on the joystick. And I packed up the bits of a byte for each of the toggles. Easy to deal with on the receiving side, and controlling the motors for that. The stop sharing. Couple things. Well, I'll jump into, here's what I wanted it to look like on the inside. That was just on my bench an hour ago. But I found connectors. It seemed really easy to hook those on where they were, but these had to be on opposite sides. Kind of forced the hand, and then crowded out these connectors up here. Anyway, I found actually these bus boards. Managed to untangle the snarl that was in the other box and get everything routed back out, and match the connectors on the motors. And yeah, I'll pull bullet connectors out here too for the hub motors. And these for driving the linear actuators off of these 2. There's these 2 headers here, leaving this one to take in the serial and do some display and other stuff. So, you know, first time make it go, second time make it work, and third time make it pretty. So there are your hub motors on there at the moment, and yeah, I read all the notes in the documentation about getting another brushless motor, a new one hooked up. But we're exploring this unit. It's got Hall sensors as well for a skateboard to fit smaller under there. So, Stephen, we may be talking about the secrets to get a different motor running going on that. What else did I want to say? It's I still love it. I love the environment. I love the power inside these. Oh, well, in the propeller, I use the 2-wheel, obviously, setup that was there. and which I knew took several cogs themselves. But on the push buttons, I played a little bit. Those are just PWM dual H bridge situations. And I used Johnny Mac's motor driver in that. And I'm not happy with it yet. Still a little chunky, but when I push a button, I'd do a slow start routine to change the motion of these linear actuators. I'd start that off in another cog so that we could still respond to other stuff in the main loop. And every time a new button was pushed, I'd start that off in another cog. It would run through its soft start and then leave it running at full and then shut down the cog, which seemed to work. It's not perfect yet, but anyway, I like that power that I can just spin stuff up without dealing too much with interrupts and stuff you wouldn't normally. So I've got to talking recently. Well, I'd mentioned boats before, differentially steered boats. And a lot of the secret to make that work had a lot to do with effectively traction control. And I was really wanting to, well, one, for efficiency. I didn't want more power dumped into this than could be effectively moving the vehicle forward. And it turns out actually there's a couple farmers, one locally here that's been working on this differentially steered tractor, remote control tractor, that has a problem of it will slip one side or the other over a clod or something and get a little steered a little off course. And there's nothing to correct or respond to that immediately, and it takes a manual intervention all the time so you don't run over your crops. But all those sorts of things, the monitoring the power and the current, and throwing some accelerometers in there to keep these things on track, are all the stuff that I'm meaning to deal with and optimize in this, help optimize in this motor control.
Well, it's good to have you using it.
And I've got several of them, and I've got too many pairs of motors and wheels and stuff queued up for this. So we'll get a lot of exercise out of it pretty quick.
It's excellent.
Yeah, Shannon. Go ahead, Stephen.
I was just going to say, Shannon, to feed your thinking, read through my document on adding the BLDC. I put the link in chat, and then we can talk. And once you read through the document, you'll have the framework of how we need to think about it to add it to the driver.
If it's been in there, I think I've read it.
Cool.
Yeah.
Okay. And we're ready to talk. Cool.
Yeah.
Shannon, are those hub motors that were for hoverboards, are those things like sufficient to push a big person around in that chair?
They seem excessive.
Oh, so you could get by with a lot less.
I think so.
Interesting.
Wow.
It's always indoors. This isn't an off-road and never on a hill thing.
So it's low friction.
This is, yeah, hard floors in a,
Yeah, if you have hard floors, that skateboard thing might just be right. Probably a little bit bumpy of a ride though.
Yeah. I mean, in the home, this in this case, it was his dad and had a stroke and needed that, was so close to independence. If he had something like this, could get around the house, and this will lower him on a toilet,
Oh, yeah.
lift him out of bed and straddle a toilet and everything. So we're talking hard floors. There might be some hard door jams or something that might be a challenge for this.
Cool.
We'll find out.
Well, come back and keep sharing,
You bet.
and let me know if you blow anything up.
So he
That
can send you
light
one of those.
emitting resistor comment, that was a good one.
Yeah.
I'm a sympathizer. Okay, so let's take a quick look at Kevin R's Kevin Bot 3, and then we'll go to the file system, unless we make another intermission with Stephen's syntax highlighting.
I'm trying to load up some of the software for it right now.
Want to have Stephen show syntax highlighting? I don't know if he's ready.
I am.
Come.
All right, I've just got it ready here.
Okay, Kevin, you're good.
So this is what I'm working on right now. Not sure if you can see that on the video. So it's got a P2 for controlling all the hardware in the robot, and got a Pi 4 compute module for all the other stuff and communicating with the remote. And right now, what I'm working on is these eyes over here. I've got two Adafruit, I think these are 1.3-inch displays. And in the software, I can change the skins of them.
Kevin, are you going to use them in that portrait mode or landscape mode?
The displays are square, so it doesn't really matter. But in the software, you can configure all that. And,
Oh, okay. I
I'm
didn't
not
know they were
quite sure
square.
how I'm gonna go about that. Can you see my screen?
Well, we
so
see your
this is-
camera.
I'm trying to screen share the remote right now.
Yes, we can see the screen.
Okay, so this is the remote to control it. It's gonna be on a touch screen, and these joysticks will eventually be physical. But you can change all the lighting settings, the eye, skin, speed, the colors, and different properties. It has a IMU, so I can tilt that and see that changing on the screen. It also use more than one remote because it's on a XB, so you can use up to 254 remotes. I don't think that's gonna be happening. I don't have a camera streaming to the remote so you can see it. I don't have that hooked up right now, but we'll do that in the future.
Aye. Aye.
And all the code is written in Python for the communications between the P2 and the remote. Right now I have servos hooked up for moving the head. Well, I'm not quite certain if I'm gonna be using servos for that. I can control that. That's pretty much it for now. It'll be pretty fun to play around with the brushless motors and see how well they work.
So you made all this
Questions?
software that you're showing us, this screen?
Yeah, I made pretty much every part of it, the remote and the communication and the P2. I made pretty much all that.
Looks pretty good.
I don't really have a way of screen sharing the Raspberry Pi, but I've got a lot of graphical stuff to control it. And since the robot will have a screen on the front.
Questions for Kevin? Everybody's intimidated. Well, it'd be cool when you get the brushless motors. Let's see what happens with that.
Yeah. Really
Looks
pretty.
like
Nice.
you're ready to move that whole test platform to something more bigger and solid, aren't you?
Yeah. I've designed a lot of the stuff in CAD. So the main frame of the robot's gonna be 360 by 360 by 510 millimeters. So
Kevin, what kind of mechanical CAD system do you use?
I'm using Fusion 360.
Okay. Is that like a web-based system?
No, it's a Windows app. It's works pretty great, pretty good for what I'm doing with it. It's free.
I see it here. Oh, it's from Autodesk, huh?
Yeah, free to students and educators.
Okay.
If Autodesk run before they turn your life into a subscription. Before you know it,
Yes.
they'll come to you and they'll steal your lungs and then put tubes in you, and then they will have to pay for the air you breathe.
That's like $540 a year.
I used it briefly 5 years ago until they thought they had better use for my files than I did when I got home. And I jumped into FreeCAD, which in the past 5 years has come a long way with CERN adding a lot of backing to it. And it's quite a capable platform right now.
Yeah, I wish I could use something else for it, but that's what I have now. It's
Well, any other questions for Kevin, comments? Okay. So come for the brushless motor control and stay for the file system. Maybe we should have chip talk, and then unless Stephen, you're ready to go.
I'm talking while muted. I'm ready and pretty quick.
Let's show. Let's
And I'm
see what you
excited
got.
to see chip stuff. So,
All right, you're up.
all right. Since we were talking about motor control, I just fired it up here. This is VS Code. And with all its ability to hover over things and see what it looks like, learning about constants and their values or where they're found. The next version will be values from within the external files. And so you can, you'll notice now it can be colored like Prop Tool. And that's all very fast and very efficient. You can see.
How do you get that going? Last time I tried doing something like that, it was awful.
Yes, I found a person that wrote code to read text within his files, which would describe what the coloring should be in extension. And through that, he had examples of how to do the coloring. And then I had to work maddeningly on taking the prop tool colors and then applying the 20 colors that I use on top of that. Excuse me. I'm trying to figure out how to make them readable again once you're sitting on colored backgrounds. But it's all very fast and efficient now.
No, I mean, when I tried it, there was an issue with the layering, that when I added the colors, it was like some things show up behind the colors that shouldn't.
Yes, exactly. This is why I had to limit. Let me show you something here. All I did was bring up the settings page through keystroke and then filtered the settings to things that affect our driver. And now you can see I have color editor background, but I also let you play with here the alpha for the background color. I limit you to 20 to 80% because of exactly that problem, Ada. If you go higher than 80%, it's going to start hiding. It's going to start hiding your cursor and your any drag through shading that you might have as you're dragging through text. And so, yes, I experienced that problem, and there's nothing more confusing than to have all the things that your mouse does disappear on you when you put color on the screen, and then you try and figure out where you're editing. And so I had to learn that and figure that out. And so now that I've figured that out, it all works pretty well. But you're right, it was quite the experience. The first problem I ran into was it would only color out to the end of the text. So I could color that much of the line. Then he showed me how I could color the full lines. So it was a late discovery. Thank goodness, most of us who write extensions share the URLs of our repos. And so I was able to take advantage of the mechanism he used and then put all the rest of the code around it that's needed for when you switch files and being efficient when you come back to the same file when you're multiple tabs. That
Also,
used to be
dark version could be better.
Say again, please.
I think the dark version could be better. I think the dark theme looked a bit weird, I think, but I didn't use it for long. I can
demonstrate that for people here. All I did was pull up the theme. I've been doing this so often now, it's all keystrokes for me. Switch to dark, and I can tell you why it could be better and why I can't do it for you presently. These are all, this entire visual interface is themed roughly by think CSS theming. It's very much the same. And what happens is they tied this editor window here to the terminal window here. And so if I were to color the background of the editor white to make these colors richer, this would come out white on my black theme background. They should not be tied, but they are currently in this release. And so I had to leave the editor background dark.
Pretty sure the editor color is separate. Yeah, from the terminal color. I
agree, but they aren't.
I'm pretty sure I have themes where they are different.
You can color parts of the terminal, but not all of. You notice we have different tabs here for the terminal. Mm-hmm. And some of the tabs are themed independently, and some of the tabs are locked to the editor themes.
But anyways, I think
I did this through
colors should just be darker. I think the background colors.
Again, you go darker in the background colors. Oh, darker?
Yes, of course. If I'm using a dark theme, I want it to be dark and not bright.
Oh, play with your alpha percentages and see if you have one you like.
That would perhaps be more useful. Yeah.
Yep, that's why I put that in there, just in case someone felt that way. I tried to hit that off. I didn't want to make the choice for you, and I wanted to make the colors recognizable initially, but you can control that. All right, so that's pretty much what I wanted to show you, is that's all working. Verbally, I'll tell you the status of the you probably heard Ada and I talking last time about how little documentation there is on when you're doing a language server. I'll stop my share now. And we're both right, there's very little documentation. And so it took me days of experimentation to figure out the interface for some of the features I need between the back server and the front client when we go to a language server process behind VS Code. reminding you in voice that the reason we're going to a language server is that it will handle multiple files, all the files in your project simultaneously. And so now I can, from the current file you're editing, look into the other object files and bring constants and documentation forward when you hover over things. And so I'm working on those extensions. What I've come to at this point is that I have now figured out the entire communications protocol that I need and demonstrated it working with no real content, but I have full communication happening.
Good question. Are you handling the weird UTF-16ness of the buffers?
I'm not having to care about that, thank goodness. It's all brought in natural text for me. So unless you show me something different where I haven't handled
No,
it.
that's the problem with the language server protocol is that all the positions are in UTF-16 characters, right? Like
But I have,
a text range.
that's very possible, but
So the problem is if you have
interface
like
provides the
like
interface.
an emoji or something in the text, it will start disagreeing on when the range starts, because the emoji is like 2 UTF-16 characters, but it's one actual character or one actual code point.
Displayed as one code point, so it can't keep track of positions.
No, it is one code point, but due to surrogate pairs, it actually takes up 2 slots.
Okay, I'm going to provide what the mechanism provides. I'm not going to, if I have people that have already done adapters or demonstrated that they have adjustments to that, I tend to use the adjustment layers that they've created that are tested and working.
Oh yeah, I'm just, because I remember that being an awful little trap.
Yeah, it may be.
Late.
Initially, most of us are not doing that kind of stuff in our code. So I want a good solid system that doesn't care about that. And as soon as we learn about that and have demonstrations of that, then we can put adjustments and fixes in to try and handle it if it's possible.
Yeah, they just love laying them traps. And also, I don't think changing the alpha on the colors works. The colors themselves need to be darker, I think.
Okay. Okay. Well, I'll work with you and we'll find a set that's acceptable. That's easy enough.
Stephen, I have a question for you.
Please.
You said you're working with VS Code here.
Yes.
When I started working with VS Code recently to work with to learn Python, one of the things I discovered is VS Code lets you have multiple different kinds of settings for different environments and languages. Which one did you choose to use in your edition here of doing this kind of work?
When you create an extension, your extension can become its own environment. And since we are our own language, everything for this extension is prefixed. All the settings and themes and everything else are prefixed with spin 2. This is the second generation of the spin extension, if you will. And so spin 2 happens to match with the P2. It supports both P1 and P2, but your themes and everything, everything I'm doing in semantic highlighting all has effect only while you're in spin 2 files. And when you step back out again to other files, the themes will still apply. I've extended, but everything else is independent. All the other settings are not affected. So delving a little bit further into the themes will still apply. When you're switching and want to switch for a long period of time and leave P2, you probably want to go to your favorite theme. What I have done is taking and done some research across most of the languages that I like to play with, C and C++, Python, and a few others, of course, TypeScript and JavaScript. I've looked into all of those and how they are semantically highlighting the elements in their language. And then I have incorporated those semantic tags into my theme. And so while my theme will apply different colors, it will still provide the variation between elements in the language in colors. So you can view a Python file while you're in an Ironsheet, the spin 2 theme, and it will look wonderfully colored and easy to understand, or TypeScript or something like this. So I've actually enriched our themes, the themes I have under spin 2, so that it feels natural and you aren't forced into switching out of the theme to work in other languages. Does that help?
Yeah, now, let me be clear.
Please.
Was the Spin2 theme created by you? Are you, okay, all right. So when you started working with Spin2 in VS Code and you did a save, then those settings became a Spin2 theme for VS Code. Is that right? Did I read that correctly?
Negative. The theme is whenever you add a new extension, it adds new parts to your settings and it adds a new collection of themes for you, and it adds other additional elements. So when you loaded the extension, all of these things were added to your environment. So now when you adjust things when you adjust settings for the Spin2 extension, they're stored into the Spin2 portion of the settings. And from then on, your environment is just Spin2, Python, whatever languages you use. It's just aware of all the languages you use.
Yeah, okay.
So I just added more capability to your VS Code through the extension.
Yeah. When I first started using VS Code not too long ago, I was very impressed by what all it does.
It's quite amazing, yes.
Yeah, it's a fantastic editor and tool.
And
But
so
those are the questions that I had for you on that. That's all.
Oh, good. I'm glad to help, Grover.
Sure.
And I think that's all I have, Ken. Let's move on.
Thank you, Stephen. That's super. Okay, Skippy, what you got? Make Johnny Mac happy, and John Huffman, and everybody else hanging around here today.
All right, let's see here. Oh, wait, let me go to our, okay, so here is hopefully we see this, oh, wait a minute. Hold on, I gotta go to, wait a sec, close. Okay, there we go. So can you see this here? So this is a P2 edge, right? And every P2 edge has this little 8-pin flash chip that's used as a boot device. So the max program you can load into the memory is like half a megabyte, 512K, right? Because that's the hub size. But there's all this extra left over. That's a 16 megabyte flash chip. So there's 15.5 megabytes that's usually never used for anything. So I made a flash file system where you can write as much of that as you want and read it back. You could also just override the pin constants and hook another one of those things up and get another 16 megabytes. If your program's only going to take 32K to boot, well, then you can start it at like the 8th block instead of the 128th block to allow for 512K of boot space. But I kind of have it defaulting to go from the 512K mark to the 16 megabyte mark. So anyway, I will show you here. I'll share my screen. Just a second here. Portion of screen. Okay, so here is the documentation stuff for this. So up here are the commands. So it has some basic things like, format, which will wipe the disk clean, mount will get it ready for use, and then I have separate open commands for read and write. So we have open, read, and then you could say byte read, it would give you a byte. When you're done, you go to close. And for open write and byte write, that's how you write a file, close it at the end. And then there's stuff for, there's a delete, a rename, and exists, tells you if the file's present, size of, how big is the file. And then there's a directory call you can make where it gives you like the next file in the directory as you go. So these are pointer values, right? So you point to a long, which is an ID right here. You point to a file name buffer. You point to a long for size. And every time you call this, it returns into these three things. It updates your ID value, which you may not really care about. It's just useful for scanning the directory. And then you're going to get a file name and a size out of that. And then stats will just tell you, how many blocks have you used, how many are free, and how many files have you got. So this whole thing, it only takes like 2 kilobytes or so of code, 2.2K. It takes a little more variable space. And I have it so you can have 2 files open now. For each file that you want to have open, it's going to add another 4 kilobytes of space into the vars. So anyway, here's some elaboration on the commands. I think it's fairly straightforward. Now to get into the code here, here is how we're using this thing here. So can you guys see this okay? So I have a little demo here. The demo actually is just from here to here, and then it calls some routines below, but we can, format. I can comment this out if we don't want to format every time, but this mounts it. Then I have some little things down here that will show the stats, like how much is used, what are the files. Then I have a read file and a write file down here. So you can see here's the process of reading a file right here. You just, you say flash, if flash is the object name, open read, and you give it a pointer to a file name. And then it gives you a handle back. So for every, you set, there's a constant parameter in the object, which sets how many files you can have open at once. And each one is going to add 4K of var allocation. But when you open a file, it's going to give you a handle that is for that file that you just opened. So you'll use this handle to reference things like, the byte read, and also when you go to close the file. So you can see here to read a file, we just open it, and then we repeat by this how many bytes are in it. We just get a byte, and then we store it, and then when we're done, we just close it. And then writing is same kind of thing. You open it, you get the handle back, you write all your bytes. And I have some strings here that we're writing that terminate with 0. So it uses 0 as also end of file. So it winds up writing a Z string into each file. So the way this demo works is it's just going to format it, mount it, show the starting stats and files, of which there be none. Then it's going to write 3 files, which are these down here. And then it's going to show again the stats, the files. Then it's going to do, if file 3 exists and apples doesn't exist, then rename, file 3 to apples. And then we delete file 1. This winds up exercising all of the API. So to run this, let me plug the Edge back into the Johnny Mac board here. So I'm using the VS Code that Stephen set up. Hey, Stephen, I didn't hear you say, because I was out of the office, but to get this highlighting like we have in Prop Tool, is that something that's ready here, or is it something you have not released yet?
It's out there. It's out there.
Okay, well, look.
I've been turning it on just now. Just have to go
Okay,
into
well, look.
settings.
If I go here and I go down to here, right?
Negative. Just open your settings.
Like the actual settings.
Yeah, open up.
Okay, so where are the actual settings?
It's like the gear at the bottom.
Oh, right here?
No, like at the very bottom, there's a gear.
Say that again.
At the very bottom, there's a gear.
I don't understand.
Or
like
if
a
you
cog.
just want to type in command comma, it should open settings as well, but the gear works.
Would I do that down at the bottom? Well,
At the
where is this? I'm trying to find where the settings thing is. I don't even know this system.
There are like 5 ways to get there.
Okay.
It's all the way at the bottom of that sidebar. There's a gear.
Okay, would this be settings?
No, below that, below that.
Oh, way
All the
down
way
at the bottom.
Yeah,
Oh,
all the way
okay. All
down
right,
at the
here we
bottom.
go. All right, so, okay, hold on. Let me drag this window down there. Okay, so here's settings, right?
Right, you click there and then pick settings from there. And then,
Wait,
you have-
settings here, okay.
right, and then you have a search bar at the top, type in spin 2 to make it easy.
Okay.
S,
Hold on.
there you go. And now scroll down to extension behavior color background. It's like the 3rd element.
right here.
Yep, turn that on. Yep, and then you're going to want to change themes. So now close your settings windows.
Okay, so just close this now.
Yep,
Okay, let me see here.
and then the same gear icon
Wait, where do how do I close these settings? I don't see any kind
At
of
the
close
top.
button.
It's a tab. It's a tab.
You have
Just
you have
close the tab.
a tab at the top.
Like,
There's a little X at the top right of the tab for settings. Just hover over settings and you'll see an X.
wait a minute.
Your settings tab is top right.
Okay, hold on, let's go over there.
And today we learn multi-document
Oh, this here?
interface.
No,
No.
under that little X where it has the word settings. Go up further in the tabs.
Oh, here, I'm sorry. Okay, all right. So close that.
Yep. Now go back
Okay.
to your bottom left corner gear again.
Okay,
In the bottom left corner gear, you have themes at the bottom of near the bottom of the list.
yeah.
And select color theme,
Okay, color theme, all right.
right? And now you can also, if you want to, you can also type in spin 2 there and then list all the themes. But if you want, right here, you see Iron Sheep light for background color, and you see Iron Sheep dark for background color. That's if you want a dark editor or the light editor. So choose one of those two.
Oh, okay, one of these.
Yes. For background coloring, this is how I name the themes.
Oh,
And then-
okay, all right. Okay, let me see.
So it's a two-step setup. You enable the background coloring and then you choose the appropriate theme.
Wait a minute, I go back to the gear again, back to settings. No, wait, not this one. All right, well, I'll just use this. This is visible, right?
Mhm.
Not too bad. Okay, so I'm gonna run the thing now. I'll have to, okay, so here is what comes out of this. Shrink it down. All right, so I'll run this thing again from the beginning. Oh, whoops, you got to close the old peanut here. Okay, here we go. All right, so you can see if the first thing it did, block used equals 0. This is after formatting, right? No blocks are used. Every block is free. There are no files. So it writes files 1, 2, 3. And then it reports we've got 3 blocks used. Each block is 4K. So each one of those files fit in their initial block. And we have 3 fewer free and 3 files total. And then it does the dir function to give you the file name, the size, and the ID. And then it also looks up the file content. So it finds first file 1. This is from the dir function. It's a 14-byte file. Its ID is 1. And then let's see. It actually just dumps out the file contents because it's short. So you can see the 3 files that way. And then I think, let's see, it renamed one to apples and it deleted one. So file 3 became apples down here. And then file 1 is gone because it was deleted. Now, if I comment out the format, right? Let's see. Uh-oh. Okay, there we go. I'm going to comment out the format. Why I can't see my cursor, can I? That's what you were talking about.
Yeah.
All right, so I'll run again. So this time it starts off because there were 2 files left over last time, so it didn't reformat the whole thing. So it found, it's just demonstrating that it, saw those 2 files there. It rewrote files 1, 2, and 3, and did the same stuff. It's showed the file contents. And of course I can, power it down and rerun it. It'll come up with these same files again. Any questions about the demo before I get into the actual driver?
I do have one. Yeah, we have a couple of us. Go ahead.
Okay.
Chip, on that last run, so did it overwrite file 2?
Yes, it did.
It ended up writing the same stuff.
Oh, Yeah, it rewrites. It wrote the same thing, but yeah, this, yes, it rewrote file 2. It lets you do that because when you rename and rewrite a file, it has to be done in a way where if power were to fail at any point of the process, at least the old file or the old file name would be still intact. So if you get a power outage and then during remount, it'll resolve and figure out that, the final switchover was never made to the new file, even though maybe it was in the process of being closed. So it winds up throwing away all those blocks because it's not sure what they were. And then you wind up with the original file. So the worst you can do is if you have a power crash on file save, the worst case is that you just wind up with the prior version of the file.
Okay, that makes sense. And then for, I guess, the normal like operation, depending on the application, might want to first check to see if a particular file exists before it writes one, if it's thinking that its intention is to write a new file.
Yeah, that's why like I did some checking right here where if flash exists, file 3, because what the thing does now is it does aborts with abort codes. So if you try to say open a file that doesn't exist, it will create an abort, which you can trap and process. But if you want to be careful, you can just say, does it exist? And then you kind of like don't need to trap aborts or anything.
So Chip, I have a question. What you got here in the files, in the memory of the file system, it's all non-volatile. Is that correct?
Totally, yeah, yeah.
Good, okay.
It's non-volatile. It's wear leveled, so it doesn't burn a hot spot in the flash somewhere. And it's all kind of designed so that if something were to happen that's out of control, like power goes out, you don't lose your data. You might lose, if you were in the process of saving a new file over an old file, you'll just get the old file back on remount.
Right.
And I'll go into the actual driver and explain how that stuff is achieved.
Okay.
Any other questions about this?
Chip?
Yep.
So I see there's a mount. And is there do we need to have an unmount?
I thought about that, but I don't know what you would do with it. I mean, until you say to do something, the flash is not being touched at all. It only gets programmed or read when you ask it to do something. So you can just remount. You can call mount again, and it will just, you know, kind of wipe out its tables and start everything over again.
Okay, I'm just wondering to make sure it wouldn't get trashed or something if you don't unmount it, doesn't leave something dangling somewhere.
You know, yeah, that would be like some sort of unfinished cache write or something. Yeah, because by the time you close the file and it returns back to you, it's done. So you don't have to worry that there's any like dangling buffers that won't get written.
Now, here's another good question. Is Wolfing thread safe? Can you call it from different cogs?
Well, say that again, Ada.
Is it thread safe? Can you call it from different cogs?
Ah, okay. Like, is it kind of re-entrant from different cogs? No, but it could be designed to be able to handle that. And it would have to have some kind of like semaphore. But that could be done. But right now, it's just kind of meant for like the same cog to you know, handle all the incoming calls.
So I have a question, Chip.
Yeah.
What are there any rules or around like the file system names?
No,
Like
in fact,
limit,
I need to
link
add
limits
some.
and that kind of thing.
It's just a Z string, so it can be anything. Now, so this file system doesn't have subdirectories or anything, because that is like another layer of complexity that will probably get added at some point. But right now, it's just a flat file system. But there are no like limitations on what characters you could make. You
Okay.
could make a file name of one space. That's legitimate. It's just a Z string. It's just a simple string match. But I mean, in the end, I should like not allow like maybe slashes as file names or things that might be of import to a future, disk operating system or something.
Cool.
If there's a number of suggestions and questions in the chat.
Oh, okay, let me look.
And Chip, I've got one for you real quick.
Sure.
You were showing the number of blocks used as you wrote the files. Your files currently fit in. How are the blocks allocated? You've got some information for directory and you've got some information for file content.
It's even simpler than that. I'll show you. This was the thing that, to figure this part out and get this straight, made the rest of it come together. But yeah, no, there's no centrality to this file system whatsoever. And that was important because we want to be able to keep it moving across all the blocks in the flash so we don't burn a hole in anything. So there's no, yeah. Now, if I were to add subdirectories to this, then what I would do is have some of these blocks have a special code, which would mean this is a subdirectory, and then they in turn would point to the IDs that represent the enclosed files. But yeah, there's no, I'll show you how, I'll explain how that works. That was the fun part. We got a few concepts figured out and then the whole thing came together. But it was really tedious to write this code because it was like keeping certain things in mind. It's like there was a continuous level of complexity that was, you always had to consider as I had to consider as I wrote the code in order to respect and mind all these concepts that were picked to enable this stuff to work like it does. Not much stuff, but it was taxing for me. Okay, let me look. You said the chat had some stuff. Let's see. Oh, lots of things here. Unmount would be useful if pins were passed to mount instead of existing as constants. Yeah. Oh, I see what you're saying. Yeah, good point. How much? I think these chips are like 70 cents, right? So you throw one on a circuit board, or you plug one in. They take 4 pins to connect. You could actually do it with 3 if you just short the DI and DO together. But you could put lots of these things on, and yeah, you could have like different hard drives effectively. You could mount and unmount. So John, I don't know, maybe we can do that. Right now I have it parameterized, but we could do it the other way too. Yeah, some way to seek. Yes, I agree. I'll add that. Also, we need to add an append layer that are used to having a, let's see, we need to have a layer that are used to having, which is more complete. Right. Okay. I see John's thing here. Yeah. Okay, this is just first pass. That's why there's only byte read and byte write, because that's like the atomic read and write operation. So we can dress those up with strings and words and longs and whatever, no problem. That'll get added. That's really trivial to add.
I want a ring buffer. Can you set me up a ring buffer?
Oh, so you just go round and round? Yes.
Just a, ensure that you've captured the data before you move it off chip, off off board.
By ring buffer, do you mean a file that just, like when you get to the end of a fixed size, it just goes back to 0 and starts writing again?
Effectively overwrites the beginning again, but you keep a few pointers there to keep track of
Well, where you exactly, yeah.
what's
Yeah,
old and
that'd be great for log files and stuff.
right, exactly.
Okay, yeah. Yeah, the only, of course, the obvious problem, there's not really a problem with that, but the ugliness is that you're going to be writing textual things of unknown sizes per entry, perhaps, so that you wind up not having a clean multiple. Like it's not an integral number of entries that make the whole loop.
Yeah. Well, I wasn't thinking just log file. I was thinking specifically fixed sets of bits or bytes.
Oh, okay. Oh, yeah.
Data from sensors.
Okay, so you would encode the timestamps and everything, and then yeah, okay. Yeah, that is not hard to add. What I have here just makes the like bones and everything, proves the bones are working, but we could add all that stuff.
What's the max length of that file name? Is it 60? That's a strange number.
Right, and that could be made way bigger, but I just figured 60. I'll explain how that works. Okay, so anything I didn't answer that anyone wants to know before I just show you kind of how it works? Oh, right, with seek we could do writes, yeah. Okay. Okay, with seek, what's really long, John? John said it's really freaking long, but I don't know if he meant, let's see, type something else. File name, oh yeah. Well, we could make it shorter, but I figured the next step down, well, it could be anything we want, but I don't know.
It seems long, but people were asking for, well, give me a file structure and stuff like that. But you can make effectively, you name it with slashes or whatever, and you effectively build your hierarchy.
Yeah.
And you move stuff to another folder simply by renaming the portion of the file name that is your directory structure.
Right.
For the amount of files that's on like a 16 megabyte flash, that's probably not that big of an issue. Just have them all in the same.
Right.
Yeah.
We just need a filtered function that only lists the one inner quote unquote directory, but that's easy to just build on top. But the file name thing was because it's an out pointer, that's kind of inherently a hazard. Because if the buffer that you make for it is too small, well, you know what happens.
Ada, that brought up a good point. What's the reason that you're passing pointers instead of just returning the 3 pointers?
Oh yeah, and FlexBin hates pointers to local variables. It hates them.
You know what I'm saying, Chip, since you have multiple returns?
Oh, you mean how I use those pointers in some of those functions?
Yeah, I'm saying, why didn't you just return 3 pointers and have no parameters going in?
Because the ID at least is interactive. You set it, it modifies it. Because I just did all 3 of them that way.
But really only the ID needs to be.
Right.
And the ID could be returned. It's actually a little bit awkward. I just compiled it and ran it in FlexBin. I had to initialize it to 0 because FlexBin didn't know to initialize ID to 0.
Oh yeah.
But
so it sounds like pass ID and return to 3 might be a more normal call sequence.
yeah, I mean, I can see why Chip did it. It's simple the way he did it, but it might be a little bit cleaner to return it.
Yeah, I didn't really think about it that much. I just figured there are 3 matters, and
I think it's kind of misleading in intent. That's what takes me down these reasoning paths.
Yeah,
right? It's like, why would I pass in the other 2? And I'm trying to figure it out. And so I always like signatures that actually inform on how I'm to use it in the cases. And this one kind of lies.
Right. Oh, I'll get it changed around. I mean, I just did it that way. I didn't think too hard about it or too much about the sanity of it. I just like figured this will work, and it just keeps three things in one place. Although it would be nice to have the file name buffer in the Flash object so that you don't have to have that also, right? Because you don't really need to declare that. It should be in the Flash object. Okay, I'm going to go. Let's
You're
see.
reusing it all the time, yes.
Okay, let's see. Okay, I'm gonna select a theme
Well,
here.
perhaps more ideally, you just have a handle for the directory. And then you could read it from that, then you wouldn't need that many in and out pointers.
Yeah. Stephen, which is a high contrast theme?
I would go to turning off the, your white is a better contrast. Your white versus black.
Oh, there we go. Okay. All right. So here's the deal. This Flash has a 4K, the smallest erasure granularity is 4 kilobytes, and it's 16 megabytes. So it has 4,096 of these 4K blocks in it, right? So within each block, you go from 0 to FFF, right? So there are 4 types of blocks. There's a head block, which can also be a last block. There's a head block, which says I connect to another block. And then there's a body block, which is last. And then there's a body block, which is more, I connect to more. So you imagine like these blocks chained together. It's pretty simple. You can have the smallest file would just use one of these. It's a head block and it's a last block. And then if you get more than that, you got to have a head which connects to a more block or a body block. Should probably call that body or more. Well, it signifies more. Anyway, this is the breakdown. There are 2 types of head blocks, right? These top 2 here. Both of them have the file name in them, and they both have a big data load. The other ones that are just body blocks, it's the same except there's no file name. It's just the data. So the way this thing works is the initial long in each block has these fields in it, which makes it handy. You just read that first long and you get everything you need to know about where's it coming from, where's it going, what is it. And then at the end of each block, there is a CRC32, right? So the block, you should be able to like process everything up to the last 4, and then it should match the last 4 bytes or the last long of the block. So that's how we know that the blocks have what we think they have in them, is the CRC32 is going to match. So the way this whole thing works, this is pretty simple, right? Just 4 types of blocks. But then down here, you see this on this block here, we have this 3-bit field right here, this VVV. And then we have 5 bits which can potentially say 32 different types of blocks. But this 3-bit field up here is all critical. What it says is when you erase a sector or before you finally activate it, those bits are going to be all 1s, right? So that means it's erased. When you activate that block, and by the way, the CRC is computed for what it is going to look like upon activation. So the last thing you do to activate a block is you program one of these 3 bits to 0. Because when you erase the block, all the bits go high, then you can selectively, put any bits low that you want. So to activate a block, you program one of these 3 zeros. And the reason there's like 3 possibilities here is because we needed some kind of like prioritizing so that we have cases where any of those combinations is superior to any other, to one of those other combinations. So what it means is when we want to do a block replacement, like let's say you want to rename a file, right? What you want to do is have the same initial block, but with a different file name in it. But it has to have the same ID. So, because if you look here, there's a 12-bit field for ID, which is separate from the block number. So when I like mount the file system, I scan through all the blocks and I make a table that relates valid blocks IDs with, or excuse me, valid IDs with block numbers. So I in RAM have to maintain a table that lets me translate from the 12-bit ID to the 12-bit block number. And the point of this is that now we can have blocks with the same ID, two different blocks with the same ID, because we have to do like a make before break when we do a file replacement or a rename. We don't want to ever have a moment of time when there's nothing written in the flash, because then we can actually lose something. So what we do, if we want to replicate a block, like if we want to rename a file, we will copy, like if I take this block, this type of block here, right? We'll replicate everything here, but we will put a superior, we'll plan for a superior 3-bit pattern in those VVV bits. So we write everything, but we keep those VVV bits high at first. Then the last step is we program one of those VVV bits to have a superior pattern to what was in the original block that had the same ID. That way, and then we go in and we cancel the final, or we cancel the original block. But that way, if power were to go out during the transition, we can go, oh, we got 2 blocks with the same ID. Which one has the superior 3-bit code? Then we know which was the up-to-date one. So then what we do is we just write zeros to the 3 bits of the one that we want to cancel and get rid of. So all we have to do is, I just write all 3 zeros, but the important thing is it no longer has 1 0, it has 2 or 3 zeros. That means it's canceled. So these are like the 3, this inactive, active, and canceled are like the 3 life stages of a block. So by having IDs instead of block numbers hard-coded into each block, we can move things around without any like issues of things being stuck in any kind of address. And then so we have this our ID field, and then we have another 12-bit field, which is either an end pointer if we're the last block, or the next ID if we're going to link to another block. So that is how this whole thing works. No one probably remembers everything I said, but I did cover the whole thing. It's a pretty simple set of concepts that work together that make this thing, you know, fault power loss tolerant. And then to achieve wear leveling, what we do is anytime we need a new block to either make a new head block to rename a file, or to begin a file rewrite, or opening a new file, we need a new block. We pick from across the entire range of blocks. We don't just look for like a block that's free. See these 2 things here? First block and last block. At block 80, if you multiply 80 hex times 4K, you get 512K. So this is where this is the default start point for the file system, and this is the default endpoint, the last block. So anytime we want to like write another block with something, we randomly pick, and I'll show you where that code is. There's a thing here called new block. This whole file system, by the way, the code's like 627 lines. Not that big. But it's the concepts that took forever to get straightened out. So here we go. Here's the new block thing. So this is like the heart of the whole thing. When it's time to get a new block, it gets a random number between 0 and the last block. And it does that by doing this, right? It gets a remainder. So it divides by a total number. It gets a 32-bit positive random number, and then says, give me the remainder after dividing by the number of blocks. So the quotient would be some huge value, but we only care about the remainder. So now the remainder is a high quality random number that is from the first block to the last block inclusively. And that's going to be the block that we're going to use. But of course, there's a conflict, right? What if that block is already in use by some file? Well, what we do then is we have to go to a free block, right? So we scan down here. Let's see. We randomly pick a free block. Whoop. And the way this works is rather than divide by the total number of blocks, we divide a positive random number by the number of free blocks, and then we index to that nth free block and we pick that. So we don't just pick the first free block, we randomly pick one of the available blocks. And then what we do is we move the block that was already in use, because we're going to be using that new block we picked, but we got to like evict the current block and move him to some free block. So we move him. That's what all this changeover stuff does here. It moves that block, and then that new block that we picked is now for us. So by doing this, it just wear levels the whole thing out, so you don't get any hot spots and you don't get any cold spots. It's like the most rewritten block is within like 10% of the least written block, no matter how many you do. Maybe it's 5%. It's not, there's not much variance, but it spreads things out so you don't kill the chip. You know, you spread that wear out super evenly. But if we were to have picked first a block that was already free, no problem. Here's your free block. But if there's a conflict, we have to move the existing block to a free block, and then we hand that new block that was originally picked back to the thing that needs a new block. So between that block stuff where you can move blocks around and pick blocks, and then that 3-bit code, those things working together makes a wear leveled and power fault tolerant file system. Those two concepts mixed together. But it was hard to remember, what order I had to do everything in order to shuffle stuff around and get things ordered the way they needed to be.
So if power failed while it was writing a block, whether it's a duplicate for a rename operation or the creation of a new file, even like a body block, you would know upon the next run that something's wrong with that block or that file, because the CRC would not be correct.
Yeah, if we didn't get around to hitting that final bit, then yeah, the CRC wouldn't be correct. But there's a point in time that's brief when you have two fully valid blocks with the same ID. And at that point, you have to look at those 3-bit codes and figure out which one is superior, and then kill the old block, and then have your table reflect the new block. And that's what this thing does here. This thing gets cycled through for each block, and it just goes and enters into the table like, okay, is this new? Has it already been declared? If it's already been declared, then we got a conflict that we need to resolve. So on this line here, if it found 2 valid blocks with the same ID, then it has to figure out like, is this block superior or inferior? And then, switch things one way or the other based on what it finds. So on remount, it just sorts through everything and then gets things straightened up. And then it also makes sure that all the files are fully connected. And if there's something that's broken, it just throws it away.
I have a question, Chip.
Yes.
When you need a new block to write, you look it up randomly. And if that block you looked up randomly is already in use, you move that block away to another randomly searched position and use.
Well, but that block that we moved to was a free block. So we randomly scan the free blocks and pick a free block to move it to. But what that does is,
yeah, but why you don't just pick a free block in the first place? Why do you move the old content? I mean, it's an unnecessary white operation.
Because if you have a case where you have a file that you keep rewriting over and over, your free blocks are going to be the same blocks over and over again as you keep writing version A, version B, version A, version B. It's going to keep toggling between like 2 runs of blocks, and those are going to become hotspots. But by always, so the first block that we pick randomly, that's always the one that's going to be used. There's only a question of if it's already in use, we have to move it to somewhere else. We have to pick a free block, but then that free block's not going to be free anymore, right? So it just keeps things flat. Does that make sense?
In my opinion, you try to wear level by writing the double amount of data. I mean, you are writing, you are choosing a block which is already written. You move that one away and then write the same position again.
Yeah.
So where you are saving write operation here, you basically, I mean, and if that second block also finds not a free block, but kind of one already used, you have to move another one to get.
It won't.
It won't.
The point here is not to optimize the writes, but to optimize which blocks are being written over time. And so in the end, you're spreading your writes across the blocks evenly instead of writing to regions which have been written more frequently.
Yeah, like imagine if you keep rewriting a file, which you do all the time, right? Let's say you have a text file, and you keep making modifications, saving it, compiling it. It's gonna like make another copy and delete the old one. Well, now that deleted old block, all those old blocks are gonna be the obvious go-tos next time you write the other file. So you're just gonna be toggling between 2 sets of blocks that you keep rewriting. And then if you look at like a histogram of who got the action, it'll concentrate all the action in this little pool of free blocks that are remaining that keep becoming free and used again. Whereas if you always pick a random block and go evict a current tenant and push him off into some other place that's free, then you wind up, the histogram winds up looking almost flat. Does that make sense?
Okay. Yeah, but I think
Grover, what do you think? Does it make sense to you?
I think one of the
I
points.
had to unmute myself. It does kind of make sense. I understood what you said, but I'm thinking about this whole thing from an applications point of view. In other words, you're reading data from a sensor in another cog, and now you want to save that data into a file that you've already got open, and you're trying to accept the data from this other cog. That's the file system's in cog 0. How are we going to get the data that you read into that file? That would be the challenge. So do you have to create a separate buffer memory area to accept that data you read in that you want to save? I think what you've got here so far is going to be fine, but I think you need to take it to the next level of capturing data and saving it to a file, because that's going to be the one main requirement that you've got to be able to do in these kind of systems, is saving the data. So that's like I said, the next level of how you approach this. And I would think maybe a buffer memory area in cog 0 that accepts that data and then writes it to the file in its own timing.
Yeah.
It's probably what you're going to have to use. Now that's just my point of view.
Right.
What you've said so far is fine, and it looks like it'll probably work fine.
Yeah,
I think I've implemented like a silly cog buffer thing because FlexBin file system also has this sort of thing where it really only wants to run in one cog, and it also hogs that cog while it reads. So I've written that a bunch of times. It's a bit non-trivial to get the ring buffer right, but I've written for reads instead of writes. But yeah, it's a whole thing. but it's you can sort of put it on top of a file system that hogs the cock. It's not, you can do that.
I did find that like the amount of writes that were occurring to the typical block were about double the theoretical minimum that you could achieve if you were to have some kind of like off system ledger of like what happened to who when, and you could just magically always know how to distribute writes. It winds up writing twice as much. However, because it doesn't allow any hotspots to form, the most important thing is achieved, that you don't suddenly get a worn out hole in your flash that you never want to bump into because it'll like blow up your file system.
What if you had in each, you're only storing stuff for each block in RAM, right?
Only store what?
You're already storing like the ID to thing mapping in RAM.
Yeah, there's two things.
But if you had another bit of RAM, you could store in each block which how often it got rewritten, and then just select the one that has the least amount of writes.
Here's the trouble though. If we can't trust RAM to keep anything in, because if you're remounting and only doing one file operation with each power on, you'd never know if you were like.
No, I mean, it's stored in the block, but you'd have to keep it in RAM so you don't have to continually scan the whole thing.
Yeah, if it could work from power on to power on and never lose any knowledge, then that would work fine. But
yeah, you just add a new field to the header of the block that tells it how often did this get rewritten, and then you can just choose one that
you'd have to take that value, that amount of data, the size of your count, from every single block in the file system.
Well, yeah, they already have like a header thing in the CSC, so you can probably add another 4 bytes to that.
Yeah, no, that could be done. You could have a 32-bit counter, but I'm wondering, I mean, that would be like pretty simple, right? You just go, you always use the block that's had the least number. It could be done.
Still, I don't think that avoids, Ada, I like the thinking about it differently, but I don't think it avoids the wear leveling problem of moving existing data. So you're going to use the same techniques whether you count blocks or not.
Yeah, the thing is,
you count the number of bytes.
You have to move existing data if you really want to minimize, if you want to avoid hotspots, you have to move data around that's not doing anything, that might be in a dormant file that is never getting rewritten, but that file is going to wind up migrating its blocks all over in the process of wear leveling. Otherwise, think about it. If you didn't move those blocks, you can think about it in reverse. If you didn't move those blocks,
those are wasted.
Then the other blocks would have to take the load, thereby creating hotspots. So by equally moving everything around, you avoid the hotspot. It's like, imagine we all lived on a street in house numbers 1 through 1,000, and there are like 100 empty houses. Well, you just pick a number between 1 and 1,000. If one of us is in that one, we're going to get evicted and go to randomly one of those free houses, and then the person of interest goes to move into the house that we randomly picked. It just so happens that has the effect of keeping the number of moves, move-ins, move-outs averaging really well across all blocks. You don't have any house that has the front door blown off the hinges because people have been in and out of it 10,000 times, and some other house has gone into twice. Wear leveling.
So not to jump off the track of wear leveling there, I do have a question about a way concurrency could be done when accessing this file system. So, and I'm just going to give an example of my stupid ugly code, which is where I just use the locks in the P2 so that whenever I access what I think of in my mind as atomic functions of the hardware, which is, you know, where you're querying the hardware and doing things with the hardware. In this case, it would be the memory chip there, where you create your lock, perform your atomic function, and then unlock it. Now that atomic function could be, you know, several things that have to happen when you create a file or delete a file or rename a file or write to a file. But if that could be done with this, you could potentially, and I don't know if you have a separate cog that you're running just to do that communication. You might be able
No, the one cog that
to make
calls
it
in does
concurrent.
the work too. It's all just simple now. So your cog is busy when you're reading a file.
Okay. So you don't, so there's no, you don't have a cog that's dedicated to just talking to it. It happens inline, correct?
Right, that's right.
Okay, yeah, and that's the way I did my Ethernet driver. And it seems like you could organize that in a way where you could just use simple locks and make
You
it
probably
concurrent.
could. I bet that would work. So when a routine is done, it releases the lock, and then someone else can try it, and then they can call one of the APIs. Or one of the API methods.
I tell you, I can't express how impressed I was with how that locking mechanism worked for whenever I'm running a web server and I'm streaming UDP data and everything into that WizNet chip, and it just works. And you can't tell that chip is doing multiple things and having multiple cogs reaching into it. There are no failures. Your cog will sit there and wait, and it's very fast. You can't see it whenever, you know, I can sit there and just hammer the web server, pulling data back, and, you know, the data is returning very quickly while it is sitting there, you know, feeding out 40 frames per second of video on my big video screen. And you can't make it not, you know, make it where it's visible to, you know, to where it would affect that. So that's just an idea that I was sitting here thinking about with trying to get concurrency to work. That might be a good way to do it.
Yeah, I could see that. That may not be very hard to get going. And you'd want to just have the semaphore work when you were doing, it really only needs to happen when you're doing something with the chip.
Yeah, exactly.
Yeah.
That is what here I tried. I stress tested that what you did, Terry. It works perfect. It's so simple. I mean, he is basically just locking the access to the FBI routines, to the WizNet. And it works with different cogs without any hiccup. I'm impressed also. It's a very simple idea and it works really nice. And that the same would work here if you simply block the access with a lock. And then different cogs can call the same. It's inline anyway, so you can call it with a cog running an own spin thing. And it has to wait until the lock is free, and then it can do what it wants to do.
Yeah, and I think that you could, let me think about this. It might be tricky. See these things here? Like this here is a table of 2 bits. This is like, because we have the, let me go up a little more here. You see this block states, free, temp, head, and body. So this is a 2-bit table, which is maintained in RAM that says what each block is. So if you're just scanning the blocks, you can stop on the head blocks, which have file names in them, and that's how you do a directory, right? And then, but here's the trouble. These things being 2 bits long are not atomic hub operations. If I made them into bytes, then, which would make it a little bit longer, then it could be fully reentrable, right? Because you wouldn't have atomic conflicts. But when you're dealing with 2-bit fields in hub memory, it's a read, modify, write. But if you're dealing with bytes, it can be just a write.
Now, Chip, if this lock mechanism is put in place, doesn't the lock cover that?
Yeah, I mean, you put a lock in on open file and you take the lock out on close file.
Well, you could, I was thinking you could do it all the way
Pretty smart.
down to when it's actually touching, when it's twiddling the wires on the flash chip. Because
Yeah,
that's
that's what I was
can't
thinking.
be.
Yeah.
Yeah.
But I think you also need to cover these state bits too.
Yeah, the state bits, or we bump the state bits up to a byte.
Well, even if it's a byte,
Need the states.
if two threads simultaneously pick the same block to read write,
Oh, yeah, you're right. Yeah,
it would be
there's
very funny
just
because
cover-
it would happen like very occasionally at random.
Yep, just
Right.
move them down into the atomic operation and, cover it by the atomic behavior.
right.
So having locks in here would actually tighten this thing up nicely.
Yep. Yeah, and think about that. What if you could come at this thing from like 8 different cogs, and you could have like 16 files open, because you can set the up here max files open. This
Right.
is how many open files you can have. So the rules are, you cannot open a file for writing if anyone else has it open for reading. But you can have multiple copies of a file open if you're just reading it, right? But you can only
Did you
have
say
one
that?
open, right?
Yeah, I was going to say, it sounds like you said that backwards.
I might have.
Yes.
Yeah.
Only one open for write, many open for read.
That's right.
But
Yeah.
But technically,
Well, that's not quite right. A certain
Right.
file that is being written can only be opened by one handle.
yes,
But multiple files the same file can be opened multiple times for reading on different handles.
yes. I see what you're saying. You're trying to map the handle's
Yeah,
lifetime to it. Okay.
right. Right.
So max files open is actually your legal handle count.
Yep. And so for each value, you're going to have 4K bytes allocated in VARs. So if you want to have 8 handles, possibly, the 8 files open, then you need to have it's going to take 32K of hub RAM.
Right. And now what is the 4K tied to? Just remind us. Is that a single block?
It's a RAM buffer for a block on the flash, which is a 4K erasable block. So you can program up to 256 bytes at a time, but you can only erase 4K bytes minimum. So I let 4K bytes be the block size so that you can just erase and reprogram a block. So what I was getting at earlier, so you see here, ID to blocks. This is a table. When you give it an ID, it tells you what block that is, and that was discovered on mounting. This one tells you, is an ID valid or not? So when it sorted through everything on mount, it might have found some valid blocks that had IDs that didn't really make sense because they were broken file chains or something. I don't know why that would happen, but in case it does, you don't want to count those as good anymore. So these are 1-bit flags, right, that tell you is an ID valid. And if it is valid, then you can use this translation table to translate that to the physical block address. And then the last table we have is this thing here, where these are 2-bit values that say, what is that block? Is it a free block? Is it temp, meaning it's in progress of being written as part of a file? Or is it an established head or a body block? So there's four states.
Of that bit array, if you just said that block 0 can never be used, right?
Yeah.
Because that's normally the boot block. I guess if you had another flash chip that you didn't use for booting, you'd lose that 4K.
Yeah, exactly. You could hook up another chip and just set this to 0 right here, right? And just say, I'm going to use the first block all the way to the very last block in the chip. But this will start at the 512K mark.
Now, Chip, how safe are we with the current flash tools?
How-
Is the current flash only writing where it needs to flash the code?
Yes. So it can only take up, I mean, the biggest download you can have is limited by the hub RAM size, right?
Yes, of course.
So it has to fit in the hub RAM before it can go into the flash. So it kind of just sets a natural limit of 512K on your biggest possible download.
Okay. The reason why I'm asking is we're going to have FlexPop users using whatever they do to flash the chip. And then we have Propeller tool users using the built-in flashing capability. I'm asking if both of these flasher mechanisms are not going to interfere with the rest of the EEPROM.
Well, I know for the scope of the tools I made, it's all fine.
Okay.
I don't know about
then,
Eric's.
is Eric still here? Can Eric answer?
I'm sorry, what exactly are you asking?
I'm asking if you download to flash your code, have you affected the rest of the flash chip at all? Or is it our file system right out there still safe?
No, it only programs the first N blocks, where N is whatever you need.
Good, good.
And,
So
and
our
it
tool
can't,
will go through then.
it can't go past 512K, right? Because that's limited by download, right?
The current downloader doesn't handle more than 512K.
Okay, so we're
You're
safe
not
to
allowed
start
to
this file
specify a
system.
location to download with the current downloader. Sorry, Chip.
Not in Flash, no.
Okay, good.
Obviously, though, it would be useful to have some kind of magic somewhere in the Flash. Although I guess there's probably enough sanity checks. I mean, FlexProp does have a different Flash file system built in that someone could be using.
Perfect question. I'm asking that. So right now we can recognize Chip's file system by finding a block that actually passes the CRC check. And we'll assume it's going to start at the 80. So that's a pretty quick check. Do we have a way to recognize your file system pretty easily?
Well, I don't know. It's not my file system, it's ARM's.
Okay, okay.
I think there is a way, but I don't know offhand.
Okay, so it's worth one of us digging into that and seeing if we have a lightweight detection mechanism we can run. Same question, but framed in a different way for Chip. Do you have a way that I can say, is the file system already formatted? Instead of just forcing a format, can I ask if it's already formatted?
Well, you could try the DIR thing. Oh, no, actually, just do the
I just
stats.
try to mount it.
Yeah, mount it and then look at the stats. And it'll tell you if anything is there. Because remember, it's like super strict. If it even thinks anything's there, it has to be passing CRC checks, you know? And so it's unlikely that just garbage is going to look like file data.
Correct. Now, in your mount, in reads and things, you're aborting with an error code. Does your mount abort with an error code saying I didn't find anything to mount?
You know, I don't even know. I haven't really documented that. You'd have to kind of look at the code to see what's going to trigger an abort.
Yes.
Let me just scan for aborts here. Okay, there's 26 of them in this thing. So, hold on here. Where's the first one? Oh. So you can potentially get a file not found. Well, actually, look here. You see these here?
Yes.
These are all the possible abort codes you could get.
Okay, so we do one that there was nothing to mount then.
Let's see, check block, and then the other one is cancel, trace file and flag. Let me see here. Here we go. So this thing here, does it have an abort? No, it does not have an abort. If I go here, the next abort is trace is on new handle. Like if you run out of handles, it's going to say, hey, we don't have any handles here. I could return -1, but But see, the trouble is then you force them to handle the error at the call, which is probably not going to happen if they're conscientious about their code design, right?
Correct, correct.
So aborts allow you to like be kind of loose and free without having to go to the extreme every call to see if something went wrong.
Correct. But this is what I'm saying. There's a couple points where I think the mount sounds like an excellent place to add an abort, saying we didn't find anything, because now you can mount and format if you couldn't mount.
Yeah.
Instead of formatting first, let's mount first and format if it's not there.
Well, but here's the thing.
Or have a failure if it's some other file system in the ideal.
But you know what? It might not find any files, but because it was just formatted. So it'd be aborting.
No, it shouldn't abort if it was formatted, because you've got to.
It doesn't know though. I mean, it's valid that there's no valid sector. That means everything is free.
Yeah, the format.
It's not abort in that case, right?
Everything.
Right.
Okay, so what you're saying is we should have. Well, isn't your mount abort I've got a fully erased system?
Well, that's what it would do. It would do an abort if the system was fully erased, because that's all it's going to know.
Right. So isn't that useful to know though? I'm thinking it is.
Yeah. Well, you
what
could
you're
just, but you could also just do a stats and go, oh, look, every block is free. Or you could just say there's 0 blocks used.
Well, but it's hard to tell. I guess if it's not erased and there's no blocks free, then that is suspicious, and it probably is in use by some other file system.
Yeah, but how you mount when after a format everything is free and you can't mount it because you get an abort because it's free.
That's
no.
the problem.
No, what I'm trying to do is I have 4 different edge cards, some of which has file systems on it. I do not want to format on starting up my code an edge card that has a file system on it. So putting format first and then putting mount after will always destroy something that's already got a file system. So I want a conditional way to say, did I find a file system out here? If I didn't, flash it, format it.
Well, here's the trouble. All garbage looks like a formatted disk.
Not when you've got CRCs.
Well, no, we'll just know that there was no valid sectors that made any sensible files.
But why does the file system need formatting then at all?
What, Ada?
If random nonsense generates an empty file system, why do we need to format it at all? Does it just erase all, make sure that they're all erased properly?
That's right. It's like garbage equals erased.
Except for that can't be the case.
But remember, there's no like fat or anything in this system. There's just this like whole bunch of blocks that have to get
kind of the tag, right? It's
a whole bunch of
block invalid. It no longer matches the CRC, right?
Right. Even erased doesn't match the CRC. So if you have a file system, if you have your file system, after erasure, you've got 1 or more blocks that have valid CRCs at the starting location.
Wait, say that again.
I think it's reasonable to accept that in random data, you'll never have matching CRCs.
Right.
In an erased file system, you'll never have matching CRCs.
Right.
If you find anything with matching CRCs, you've got your file system.
Yes, but you know one thing I do though? Okay, look at the pattern of these this 3-bit pattern down here. If I find a sector that doesn't have a valid this and a valid CRC, I change it to 0 so that next time I don't waste time loading it in and doing a CRC on it.
Right, of course. What does that have to do with recognizing the starting state of we found a file system or not, though?
Well, but you see, there is nothing that makes the file system unless there's like a body, like a head sector, which you have to have at least one head sector that might be the last sector or block also, or maybe a head sector and a chain of blocks that make a file. Then you're going to see that, oh, there's something in the file system. But if you
Right,
don't
now-
have all that, there's nothing in the file system. It's as good as erased.
Agreed. Now, in the case where you have, so what you're theorizing is that, I don't know how to state this tightly. What you're theorizing is that you've got blocks that could look like they're in a repaired state or need to be repaired state. If you had a power failure, how many of those blocks could you have maximally?
Only one. Only
Right.
one.
Right. So a file system is a legitimate file system is one or more blocks with CRC checking, and possibly one more block that has a CRC failure and the flag marked incorrectly.
But if the CRC fails, we don't know what. It's just like.
But you see
dead.
what I'm saying? But you see what I'm saying? In the case where you search the entire space and you have one CRC failure, that's a legitimate file system. In a case where you have, and that's excluding all the fully erased sectors. So I think there's an initial startup scan that actually can identify whether your file system is there, even with a single flawed sector.
But we don't know the extent of the flaw.
The flaw is one sector. The flaw is only one sector ever on a write failure.
Right, on a power failure during write.
Correct.
So what we're going to have on a power failure during write is we're going to have two. We're going to have two.
Matching blocks, but one has a bad CRC.
No, they're good. Because we just hadn't.
Oh, they're going to be
canceled the other
identical.
one.
Yeah, they're both good You're potentially good CRCs then.
So we have to then look at the 3-bit code and figure out which one is superior to the other, and then cancel the inferior one.
But they both have good CRCs?
Yes. Yeah.
Okay. So on a
Because
failure, you've
that's
got
what
all
makes
good
it-
CRC blocks.
That's what makes it recoverable.
Okay. So on a failure, you've got all good CRC blocks. So a file system of yours at any state at power on will have a collection of erased sectors and a collection of good CRC sectors.
Yes.
So random data doesn't match either one of those two patterns.
Right.
So we can assume that if you've got a random sector block, we don't have your file system. Is that legitimate?
No, wait, say that last sentence again.
If you found a block that is really random data, we can assume your file system is not sitting there as one evaluation criteria. You're searching all blocks for empty. You're searching all blocks for legitimate CRC. But if we found a block that has random data, something overwrote part of your file system.
Well, here's the key. When I look at a block, you see these 3 possibilities right here?
I do.
If I see one of those, then I read the block in and check the CRC, right? If I don't see one of those in these VVV bits in the first byte, because that's the first byte of the 4K byte block. So the top 3 bits of the first byte have to be one of these 3 values. And if they're not, that sector is no good. Just ignore it. But if those 3 things are there, then we read the block in and we kind of check it. We do some things, look at it, make sure it all makes sense. And then later we connect those blocks. We verify that they all connect together. There's
right.
So there's no just body block out there that doesn't attach to a head ultimately or via a head. And that there's no head out there that said there's more to me, but then there's no more anywhere.
So it sounds like what you're telling me is that in your current code, you don't have the logic to defend against writing against a file system that was yours but is no longer.
Well, if it can't resolve, if it can't see one of those three-bit patterns, and then if it can't match the CRC, then it's just garbage. And what it does though is it'll hit that sector with 3 zeros in the VVV bits, just so that next time around, we don't waste any time on it.
So what I'm thinking through is the lifetime of pulling these P2 edge cards out. Time goes by and then putting the P2 edge card back in again. And we're running some code that has your file system. During the time it was away from running your code, lots of things could have happened to the EEPROM on that card. It could be Eric's file system was put on top of it. It could be erased. It could be some other blocks.
Oh yeah, those are
some other application.
Those are
Okay.
deal stoppers.
Right. And so
But that seems
the way I like to think
user
about
error.
right,
If you-
it is user error. But what I like to think about this is in my environment, I would want to adopt a practice that helps prevent me from making the error that destroys data. So that's how I think about this. And I think if our customers have things written to their flash chips, they would like to have that protection as well. That they're not going to accidentally do something that's going to wipe out their system. And so we as implementers of these systems kind of want to think about how their user data is valuable, even if it's put out on EEPROMs. So how do we protect them from shooting themselves in the foot just by putting it in and running some code accidentally? That
Well,
wipes
if
out
the
their
end
code.
user of a thing then and tries running a different application that uses a different file system, and then somehow doesn't expect that the previous data gets overwritten. That seems a bit like a rare idea.
No, but actually, Stephen's got a very good point, and I think we could do something meta, like we could have one block somewhere in the flash that we write to and says, this is formatted with CHIPS file system, or this is formatted with little fs, or this is formatted with FAT32, or
Oh, I see. Some kind of thing where
something
like road signs.
yeah, something like an MBR.
Right. Right. And then what happens is we have created multiple file systems. We've created a user space where we can choose the file system that we want to use, but we've also created the safety protections for our users that they don't actually wipe each other out accidentally just because they forgot they had done that because it was 4 months ago or 8 months ago.
But that doesn't work either, because you could say CHIPS file system from 512 to say 2 megabyte, and after that I have the flash file system of FlexProp with another 4 megabyte. I mean, we can have both of them. Both of them work from sector X to sector X, or from the page.
From their own respective regions of the flash is what you're
Yeah,
saying.
so we could have both of them. So
Yes.
that thing we make one marker sector, I'm CHIPS system wouldn't really work then, because I have CHIPS system and Eric system on that.
Well, but if we have a space, like I say, something like an MBR partition table.
Or a file description file that is the smallest possible allocation size. So we write the smallest possible file, which says, I initialized this particular file system at this range, and I wrote that as a single block in the file. And so as soon as I set up chips, I'm going to lose one block to this purpose. As soon as I set up the one Eric's using, I'm going to have one tiny file allocated to this purpose.
I don't think we can do that within the file system, though. I think we need some kind of metadata somewhere in the flash.
Right.
Like in
Exactly.
sectors.
This
I'm
is
okay
like,
with doing it outside of the file system, but having the metadata there is cool. Let's go to 81 then and make 80 the signature block. Something like that.
Yeah, that would work. In practice, when we boot from flash, I guess we do read the first.
yeah, you just
Correct.
start reading from location 0.
Right.
Yeah.
Well, it doesn't, I'm not necessarily a fan of starting from a fixed location. A name sounds better, so it can be anywhere.
Well, but to find the name, you need.
Right. So we come up with a consistent name for whoever boot system is running.
But it can't be on a file system because what if it's little files, little FS is on there?
Yeah, it's kind of a chicken and egg problem. And then every file system has to like be aware of this and then look and see if what his permissions are.
Oh, so you're
how do
talking-
you distinguish between an arbitrary different file system and just the flash being erased?
Yeah.
Well, I like
again,
the
Or just-
81. I
or
mean,
maybe
sector
you,
81.
I don't know,
is-
pull the flash from something else and do want to overwrite it.
Well, again, we always have to allow the user to fully erase. No matter what, we have to allow someone to take over a system that they no longer care about. That's fine.
But I don't think we need anything particularly sophisticated. We don't need to wear level the file system information because it's not going to change
Right.
that often. And we just put it somewhere fixed in Flash. I mean, 81 might work, although then there's the question, what happens if we someday do a 1 megabyte P2?
Right.
But,
Hey, Eric, does
But
this
coming
give
up with
you a
something-
sense of deja vu at all?
not quite, although I've
Well,
done
like the
things like
clock
this.
settings, you know?
Oh yeah, like clock settings. Yeah.
So you guys
Well,
deal with something like this before with trying to determine a standard for us?
Yeah, for
Well-
like where to store clock settings.
yeah, that
That was like COVID. No one wants to think about that.
no one
Chip,
wants
can
to
I make
do-
a suggestion?
Yeah,
Since I've been playing with the code that you sent me. I think you ought to make your error codes negative because
oh,
you
I saw that. Yeah.
now that you could have, if you're manually creating a file, or a new file handle, you could get file handle 1 back, but your error code for no handles is also 1. And so you wouldn't.
Okay. I see what you're saying, but here, yeah, so you just say if it's greater than 0, greater to, or if it's positive, we're good. But here's the trouble though. We then have to put the error handling at that call, or, after that call every time. Whereas if we have an abort, it can go to some other place, up the call chain and then say, hey, I had this problem. Because
Well,
if you
no, that's fine. I'm just asking you to change your definitions. Just make them negative.
Problem is that you can't distinguish between an abort and a normal return. The same
Right.
old problem.
Exactly. And so I did it. I made a copy and I just changed the abort codes to negative, and then I tried to open a third file, and instead of getting back error code 1, which would have been the second valid file handle, I got -1, which says, okay, I can't open.
no handle.
It's not
Well,
a valid handle.
Okay, here's the way spin 2 works, a little different than the original spin. When you do / and then you call something,
Yes.
you're only going to get 1 return value. And if there was no abort, it will be 0. But you won't get the normal. That's not how you get back normal.
Oh, that explains the problem I was seeing. Okay, well, here we go again. We've broken spin from what we're used to for 14 years, and now it's busted again.
There's a lot to get upset about. I understand. There's just, I don't know if negativity,
unnecessary.
I mean, negative numbers make any difference, because here's the thing. When
Well,
you
just-
do / and you do a call, so you're going to get back the abort. If there was no abort, by default, you're going to get 0. If there was an abort, you will have designed your error codes to be non-zero values, right? So you're going to get a non-zero if there was really a problem. If you get a 0 back, there's no problem.
Yeah, but if your function returns a handle, it returns 1, 2, or 3, and you can't distinguish between error 1 and handle 1. So
But
having negative error codes is also kind of I mean, the only thing else I know which is using abort is that Kai's SD
But-
driver, and he is also throwing negative string addresses basically. So negative abort codes would be smarter than positive ones.
Well,
It
you'll
doesn't
have-
matter. They can be out of the range of the normal files, but I'm looking at new handle, that method that you have, and it has a handle return unless, you know, there's no files available, then it doesn't abort. So
But see, here's the thing, if we have it, what you're saying is, if it has a problem, have it return a -1, right?
or just a code that doesn't look like a valid file handle in this.
Yeah,
case.
any negative number would do. That's true, but then the thing is, it forces you to always deal with the error at that call. So the nice thing about having aborts is you can put that exception code elsewhere. Now, if you're coding carefully, you'll prevent those aborts from happening, right? Which is
Well,
the ideal.
One of the things that I did, because I was seeing something goofy, so I added a feature called, you know, open files, which goes to the handles and counts up the ones that are used, and it'll tell me, so I don't try to open more files than necessary. But it's just,
Oh yeah, that could be handy. Like if you want to have a whole bunch of audio files open,
right.
you can let,
Yeah, again, I just don't want to try to since new handle, you know, since the abort thing doesn't work the way it works in spin 1, I have to just figure out, I have to adapt to this. Again, you know, I know I'm not as smart as anybody else on this call, but I do deploy this stuff and I need practical solutions, not, you know, hairy-fairy, oh, maybe this will work sometimes stuff. I got to have it work.
Got to be stable code, and it's frustrating to have different mechanisms when you're switching languages, when you're.
Well, especially since I've written
both.
thousands of spin 1 programs and I'm trying to port them over to spin 2.
Yeah, that's not an obvious failure you'll see in that.
And
port.
that is it. Yeah, that's a very big thing. And I have used abort many times in spin 1 and
Well,
it's really
in
nice.
spin 2, I think the abort actually works way nicer, because if you do \method, you're only going to get one value back. 0, if like, let's say that the thing returned without an abort, you're going to get a 0. You won't get any parameters from that method. You just get a 0. But if
Well,
you did get an
Oh, that's
abort,
worse.
Why then? So maybe this is something that was just an oversight and needs to be reconsidered. You have a method called new handle that either returns a valid handle or it doesn't abort.
right?
So you know, so that's where you know it becomes odd.
So you can't handle the abort and simultaneously receive the valid handle if you have one.
Yes, exactly. Yeah,
So
'cause
we have
handle is supposed to
decide-
give you the next free handle.
So, okay, well, I could make it return a negative code on no handles, but then we wouldn't have, okay, you wouldn't get the option of having it handled through an abort, and you would have to check for it.
No, the problem is that
You have to
abort
check
sucks.
for it every time.
Well, yeah, I see what you're getting at, Chip, but I'll agree with what Ada just said. In that case, I would rather look for a code and say, hey, that was a problem, instead of having, in this particular case, have the code shoot all the way back up to the source call and not understand what's really happening.
Yeah, I think, Chip, what you're working against is we've got, as long as file systems have been around, we've been trained that system calls, we have to deal with the error code. We've been trained on how to do that. We have patterns we use that work really well for handling those kind of cases. And each of us has their own style for handling that. But in the majority case, we're looking at return values for system calls.
No, not really.
So-
It depends on
so-
the language really more.
No, I agree,
Some of them
but
have
you see my point.
exceptions.
You're fighting against trained and world experience by changing how we do it. And so in that case, when you're fighting against something, it's probably worthwhile putting in both mechanisms if it can be done, or adopting the larger, more prevalent mechanism if it can't. that way, the majority of your population that thinks this way will actually be effective in what they're trying to implement.
The problem is that Spin doesn't have any way to force you to check the error code, and not having the language enforce that you check the error code before using the value as if it was valid is just a very bad idea, because in practice no one will do it then.
I'll say that again because I'm not quite sure I'm with you, Ada.
If you have like a C, you know, and you like open a file and it returns a handle, and it might be null.
Yes.
About 50% of the time that someone has written that, they probably did not check if that handle is null.
Right.
Yes.
Like, it's very easy to forget doing that, and a lot of the newer languages will not let you just use the handle like that.
Yeah, they'll try to
Correctly.
use a null handle and get into just more trouble. It just creates a snowball of problems.
And how is that different from we have just a new coder coming to the system and they just don't know to do that?
Well, you can, okay, to set up an abort trap, it's only one layer of call, right? So you could
Problem is that now when you add another layer of function to catch that abort, now you can't be sure about the return value of the function that you're catching the abort outside of.
why can't you be sure about it?
Well, on the spin 1 style, you don't know if it's a spin 2 style, you just don't get it.
Right. Yeah. When you do the backslash, you're saying that I'm only going to get one parameter out of here. So if everything went fine, or you just had a straight abort, you get zero.
One return value, you mean?
One return value, yeah, which will default to 0. But if you just hit an abort, it's going to be 0. But if you say abort 1, you'll get 1 back. But you're going to get
There's no way to get
0.
the actual return value. It's kind of bizarre and strange.
Yeah, it's like you're saying, I don't care about the return parameters. I just want the abort status.
But we want both. You need both of them.
I understand that, Chip, but what I don't understand is why you would put the abort mechanism in the new handle method, which is supposed to return to you a valid file handle if it can.
Yeah, if it can't.
You have to allow the if it can't case to happen.
Problem is, if you call new handle, or well, open write or something, if you call it without the backslash, it will just bubble up and be awful. If you call it with the backslash, you can't get the handle.
The handle, yeah, exactly.
It's
No,
stupid in both ways.
You have to have a layer of method. You have to introduce another layer of method to trap the abort, and it'll never come back to that until it's done, whether it failed or not.
But why? That's a very jank way of doing it.
Yeah.
It's not a normal way to do it, is what you're saying.
Well, the way other languages do this is they have like an in method exception area, right? Where you say try to do this, and if you accept, then wind up down here.
Right. And so how would we, with this mechanism, implement a similar thing? What you're saying is all the exceptions float up somewhere and are implemented somewhere.
Good question, better question. Let's say you have a function that wants to read a number from a file and returns that number, and like returns a default value if it doesn't. Now you have to like define 3 functions, I think. Or maybe no, it confuses me. See, actually no, you couldn't do it at all, I don't think.
Right.
Now that I think about it, make a function that like reads a number, just read the first byte of the file and returns it. It's impossible to actually do, because you have to catch the abort somewhere, but you also need to get the value if it didn't abort. So
yeah, there are these problems that there's really, they have to be dealt with, and there has to be things to do when everything fails. Like the thing I always, in Delphi, we have try and accept scopes, right? The trouble is, what failed in the try? You don't even know that, right? If anything accepts in the try, because you might have multiple things in the try section that could cause exceptions. So when you get down to
But Chip,
But how
the thing
does
is-
the
thing is
have
you have
moving
to
it to
count-
method call sites improve that? I don't think that really makes it any better. In
I
fact,
think
it probably makes it worse.
let's
Especially if you
dissect the
don't have
proposal.
structured error types.
Right. Let's dissect your proposal there, Chip. When you have multiple things in there and you have a try exception block, the reason why you can't tell what happened is because you don't have try exception blocks in the areas where it's really important. In the areas where it's important is wherever the failures can occur, being as close to that as possible so you can tell why it failed. We trained for that for years. If you are writing code and you're not capturing errors at the lowest level possible, every time you don't do that, you're losing information about the context.
Right, right.
So if your coding style is to not do that, you're choosing to lose lots of information that could help you find and fix the problems very quickly.
Okay, well, that's fine. Well, what that means then is that every code written has to be able to handle every potential error.
Negative. They're only simple. If you look at the failure modes for your abort cases, there are not 5 abort cases for any one of your abort cases. There's only one in each case. So if I'm going to invoke that method that has that single invoke abort case, I'm going to check for it. And the only reason it's an abort mechanism versus the return code is the style of code we want to implement. We want our users to implement. So in a sense, the abort case is useful if you don't care about the information around the failure. And I don't mean to be critical, I'm just trying to point out what's effectively happening when you try and use this mechanism. If you don't code to handle the abort at the level where you're making the call, and you know precisely which abort is going to be used, it becomes less useful.
No,
So
I know what
one
you're
of the
saying.
suggestions you had was putting a high-level abort capture mechanism. And then one of the things you're hearing from Ada and from John is that, but that high level is not helping us solve the problems. And in fact, because you're hiding some of the information at the failure time, we can't solve the problems the way we're used to solving them, is the way I paraphrase what I'm hearing.
I
So
mean,
you
some
might
of them
have-
aren't actually solvable. If you think about the file idea, right? If you about the read number from file idea. So let's say you write it like a normal person and just catch all the errors as they occur. So you know, did I fail to open the file? Did I fail to read the file? Did I fail to close the file? And well, you can't do that because you can't get the results from the methods. Okay, so we move the check up into a separate method, but now the method that reads it can't return the byte that it read into the upper method because that one has the abort guard on it.
The abort short-circuited the normal returns.
You know,
It's just not possible if you have to pass a value through the abort, right? Like that's an issue.
How about
The
sorry.
abort barrier prevents you from returning normal values. So like you can't implement anything that returns a value and might abort because you can't actually return the value if you want to capture the abort.
well, how about this? How about every time the file system does something, it logs an error status in a variable that is associated with the handle, and then we can have a method to go and look at that error status whenever we want to see it.
Almost basically
That would be more workable, but the problem is that A, you didn't solve the fundamental issue at the language level that abort sucks, and B, you need to actually check that variable, and no one wants to do that because it's awful.
I don't agree with that last part. I've done that, what Chip is suggesting, and I've worked with devices that after a process, there was an error code that could be checked. 0 meant there was no error, and everything.
The problem is that it's very easy to forget doing that, and it's generally considered a bad design, at least.
Well, at some point, we have to take responsibility for writing code. And so if errors could be generated and we choose to ignore them, then we do it at our own peril.
Well, yeah, that's
if
the
you don't
ultimate
choose to
problem.
ignore them, you just ignore them because you forgot to write the handler.
Well, okay, well, then when things blow up, you'll figure it out.
Right.
Yes, but maybe it only blows up when the flash is full or something.
Okay,
Again,
fine. Yeah, you won't
as-
do it
as those
twice.
of us, right, as those of us that are doing code for production, we are always very careful about making sure the states of our devices and the states of our library routines are in a predictable, that we've handled errors that occur. Because once we field the code, we can't afford to have our customers discovering those problems. It will do nothing to our reputation to have customers discovering those. So
Well-
those of us that do production code under contract are always handling return codes. And
How
are
about
always,
one simple solution maybe would be a spin variable called error or error number or whatever. And Abort would not return that value, just write it in that variable. So you can abort in the same line in your open file.
But then you still can't tell
then you
whether
can
the
check an
abort
last
happened.
abort code or last abort either is a 0, so that abort doesn't return but writes that value into a space
Okay, so
that the
just
user can access.
Well,
I think the
think
least awful way of doing it is to just, instead of the abort trap, just replacing the return values, it just makes the first return value the abort value, and then the second value is the actual first return
That
value.
would also be nice, yes.
That I think just makes it work.
so what, yeah, and so what we're coming down to is the needs are strong enough that we probably need a different signature for system methods like this that help us handle these cases. And maybe the abort mechanism is not the right way to do it.
Right. Oh, yeah, there's, like you said, we could pass a second parameter. We could,
Second return value, you mean?
I mean, a second return value, or we could have a, we could get, when we open the file, that the handle that we get back could be used to always index into some error code that we know the base address of. You know, there's lots of ways that it could be done. But like John was saying, ultimately you have to handle, if you're gonna be fully responsible, you have to be ready to handle all these errors in some fashion.
Yes, but the thing is that as someone writing like a library or tool, you should make it as hard as possible to forget to handle the error.
Yeah. Okay, well, then the forced second return value would be like, you know.
Yeah, what I think is if you call with the backslash, instead of just making it one return value, you make you put the error code first and then come the normal return values. So if a function that returns two values, like an A or a B, and you call it with the backslash, you get the error code, you get the A, you get the B.
Yeah.
That makes it so you have to get the error code into some sort of variable, which probably makes it very likely that you're going to check it.
But technically, and I'm okay with this, you could still ignore the error code if you said underscore comma B equals function.
Yes,
And,
but that makes it explicit that you're
I'm
ignoring the
okay
code.
with people choosing to ignore things. I just want to have, I want to, you know, again, I'm a simple.
Yeah, but you have to write it like that to make it ignore it. So it's like when you're reading for the code, it's very obvious that it's ignoring the code.
I understand that, but
And
here
that's
we have a
purposeful.
function.
It's useful.
We have a function in the current version of the file system that wants to return a file handle, but it has an abort in there. So it can create a problem. I mean, it just seems like that's not how we should do functions.
So
Right.
with the way I proposed it, you'd call it with the backslash, you'd get the error code, you get the handle. So you check, is there an error code? If there's not, and then you use the handle.
I think so. You're expanding the definition of abort. And so as we learn to use that, we'll always think in terms of we get both of these pieces now from here forward.
Yes.
Is that fair?
And you could do that with standard functions too. You just say, hey, I'm going to return two values and have the first one be error code and the other one be function value.
Yeah, you can do that with normal functions as well.
Right. And so what I like about the normal functions solution is it's actually better documentation.
Exactly.
Self-documenting. We will learn that two values are coming back. We'll learn that one of them is an abort failure indication. And we will always code to, if we want to use that information, we can, or if we choose to ignore it, we will actually write in the code that we're choosing to ignore it, and that will indicate something to our readers as well. So I like the self-documenting rather than hiding an abort. It sounds like that the abort change is useful enough, however, that we might want to consider that in addition.
Well, you could make it, when they mount the system, they could define if they want aborts or not.
Let's not complicate things. Let's just make it work.
Yeah,
Well, that's the
think,
trouble.
well, I think making the language features rich enough to work well is something we should do. So changing the abort might be a useful thing to do. I think making these functions of something that we're going to use in production code work well and be well documented is something highly useful to do, because we're all going to be writing to this. And so we do need to pay attention to this. And John, you've done something really good by early detecting that this is a problem for the file handling mechanism and needs to be addressed. I think as we all get on top of this file system, we're going to be want to be learning it with a critical eye and learning for and paying attention to what makes it hard to use and what makes it easy to use, what's documenting, what's not, and make those kind of changes so it's better for all of us. Does that sound right?
Yeah, this is the kind of thing where there is no easy way out. You know, it's going to be one type of pain or another. So we have to figure out what's the recipe for the least pain and the most function, but still gets you the granularity of error monitoring that you need.
And we've got a lot of world examples for how this is done well.
I think Ada's idea is probably, when I got that right, what she said, is if you put that abort slash in front of a function, it just returns one value more. 0 for no abort, and
yeah, 0 on no abort, 0 on a straight abort with no value. Or if you say abort 1, 2, 3, then you're going to get 1, 2, 3 back.
so
Well,
basically
should probably be a value that's not 0 then.
But basically the idea would be there that if you have a function returning 2 values, it will return those 2 values. If you put a slash before it, then it will return 3 values. So you can use all your function like you are used to, but if you that function where you put that abort check, that will return 1 value more. The abort is first, and then what it would return normally.
Not to cause a problem with all this discussion, but Chip needs to get going.
Okay.
I can be here for just a few more minutes. I got to be at this place at 4:30, and it's about 10-15 minutes away.
Because well, don't let us keep it, Chip. There's been a lot of discussion.
Yeah.
So I will post, since Chip was kind enough to send me a preview version yesterday, I started writing a really simple little kind of shell program that runs in Propeller tool just to experiment with that. And then I had added a feature. Chip then put it better in the thing. And so I think doing real world practical things, because one of the current stuff only does these little tiny text files. You know, I'm going to be storing big chunks of data for my friend John Huffman. You know, we've got a couple of camera control projects that need a lot more than 4K of data. And so experimenting with that in a binary, you know, with binary.
Well, John, you know, you can have a lot more than 4K of data.
Oh, no, I understand. I understand. It's just a process, you know, for example, and I will stop because I know you got to go, Chip. In FSRW, which I was kind of, you know, I was talking to you about in modeling, when you do just a generic read, it'll tell you how many bytes came back. So the idea is that if you know that, what I'm trying to get at it not very articulately is, if I'm reading from a file, how do I know I'm at the end? Now, FSRW will tell you if you're trying to read into a buffer that is n bytes long, if it's less than n bytes that it reads back, then you know that you're at the end of the file.
Yeah. In this
These
case,
are some practical things. We need to do some real world tests and tools so we can say, okay, here's a 50K digital file, you know, let's read it in.
Right. Yeah.
Yeah, John, I think what's missing is there are many of us that are familiar with many different file systems. And so there's a union of file system calls that rightfully should be a layer on top of this, so we can just see this as a file system and just know how to work with it.
Right, and as Chip pointed out, earlier, he said, hey, this is the bones, let's get the bones working. And I'm throwing on some of that API stuff that you were just talking about, Stephen, just because I trust Chip, and I thought, okay, I know that the code's going to work. Now we find,
Right.
you step into little tiny, nits and things here, but, there's some personal stuff here for me, because I got my butt handed to me by my boss in Dallas last week, because we're not finished with a project that needs this.
Okay.
And, so I don't like that when that happens.
Yeah, I can appreciate that.
So Chip, what will be the best way to get continued discussion as you need to leave? We can end the recording, but you put the link to the forum. Will be the forum where you post this, maybe the best place?
Yeah,
you
probably. So, yeah.
You
Yeah,
get all
I'm
the
going to
feedback.
post my demo in Chip's thread.
And
Okay.
I've Stephen Morocco could take over with the whole. I mean, there's not much code here. It doesn't take that long to get a grip on. I mean, it could be dressed up in any number of ways, and it's there's, once you understand the mechanism of what's going on in there, it's easy. Like John last night figured out how to do a file size. And so it's, I don't know, we could go lots of directions. But the important thing is, though, that it works at wear levels, and it survives power down. Those are like the important things.
Yeah. Now, from my standpoint, because it is, as Stephen was saying, there are general, file system APIs that we've all used in different languages, and I'm always in all the product development I've ever done, tried to do things that people expect. So when some of us out of this group, somebody new to Parallax says, oh, okay, here's a file system driver, it seems familiar.
Yes. Yes.
Yes. Although my way would be just like, well, who cares what's been done in the past? What is just the most simple way to approach it?
Right.
Well,
And I think from a go ahead. I'm sorry, John.
sometimes
No,
it's
no,
useful
I'm
to
just,
just
I'm
think about what's
laughing and
actually
scoffing
needed and
because, humans
think
don't
about
think
the
that
new
way,
one.
Chip. So do what's simple underneath, and then the layer, that interfaces with the customer, make that, again, familiar so that it's easy for people to incorporate.
Right. The idea being, Chip, is that people who write code have a lot of world knowledge about how to do things. If you make it really unique, they can't apply that world knowledge to what you produced. And so we take and put a layer on top of it that allows people to come to this with that world knowledge and just immediately use it.
Yeah.
Yeah. Well, think of this, like, let's say you just want to have a single open method, right? And then you say in there, like, what do you want to do? Read, write, append. That's, you're going to have, where are those constants going to come from? You're going to have to say like flash dot and then name the constant as the parameter, or have 1, 2, 3 or something, or some kind of, you're going to have
characters R, W, like all.
Yeah, exactly. Like everybody else does, use characters.
Yeah, we'll pattern it. We'll pattern it after what
Oh, I see.
And so now,
yeah,
we'll do whatever we need to do, and we'll translate that all into your calls. And so in the end, there'll be a thin layer on top that does this little tiny translation and then calls your underlying. And so all of us who come to it knowing how to do this can just call the top level layers, and we're sacrificing a little bit of memory to contain that translation layer, and we're sacrificing a little bit of translation to and from intent to it actually happening.
Yeah, because most of the hardcore
deal.
stuff are private methods anyway that are not going to be exposed to the caller. So it's just adding a few more niceties to the public methods to make it seem very familiar.
Yes.
Right.
And once we've achieved that, the adoption rate, just like using Eric's that he's got, the adoption rate for this will be the same. And so I would suggest that we even pay attention to make sure there's a union between FSRW, whatever Eric has, and what you have as that API layer. And so we can flip over to using whichever one we want, and the code doesn't have to be that different.
Hey, Ari, can I turn the meeting over to you?
Oh, I'm actually the host. But what we can do is stop the recording now, and
Okay.
so you can leave.